Nice spot in the back of the room. That's mine. Thank you all for participating. As you see, we had a very nice group picture, so I wanted to put that up for the team building feeling. Thank you again for the wonderful dinner. Thank you very much for that, and for the hosting. We have still a big day today. We have a couple of vendors that want to show the IDS to IFC check after lunch. We have a lot of people, including myself, that need to leave on time to catch transport. And we also have the playground tour. And we have Greg all morning with big topics that can take 2 days, but are squeezed in to just a couple of hours. So we're sticking with the theme of having way too much content in way too less time. I think it is important for me to mention that what Greg is doing is quite drastic. And we fully support that. I think it is really good to go drastic. There's quite some things that we need to change in IFC. Not everyone will like the fact that it is so drastic. Maybe we need to scale it down a little bit, but I think the message that I need to send is that IFC 5 will indeed be pretty drastic, because that's needed. It hasn't really been changed since the late 2000s. So I think that what Greg is presenting makes a lot of sense and is very exciting. Do we all know Greg? We all know Greg. He needs no introduction, right?
But it's useful to do an introduction because it's important to know I don't develop software for a living. So don't blame me when I make assumptions that I have to figure out without doing it myself, let's put it that way. But yeah, so I'm an architect by training. I work for HOK. I will be crystal clear. I'm like 50% doing this for the good of the world, but at the same time, HOK has been involved with buildingSMART since its inception. I want to make it good for us too. So it's a selfish but selfless, let's say, activity. Hopefully that's clear. So we have, don't count the slides because we're going to start on 147. We're not going to go to the, and there's more than that. So we'll start with a blank slide. Let's go. Okay, so what I have to walk you through first is we started this thinking, I mean, I think the initial ideas in talking about IFC 5 started, at least my involvement in a meeting in 2017 we had in New York that brought together a bunch of people to start to have this conversation. Didn't really end with an outcome, but I think it ended with starting to understand the key things we needed to address. And so what we've done over the last couple years, like let's say pre-pandemic, was make sure we understood the generic stuff that we needed to sort of address. I'm getting an advertisement in my presenter view in PowerPoint. I gotta love Microsoft. And so we've started there, but what you quickly realize is, like, if you take all the requirements, you have to do something slightly different. So I have to walk you through the process to get there. So the first thing, like, this is just sort of a basic concept, which is, well, we need better change management because change management is important to nearly every workflow we have. Updates, working with clients, all these things. So there's this sort of challenge we need to work through. And so then you can take a very simple view and it's like, okay, well, I just need to take what everybody's talked about for a long time, is take a step file or a IFC express file, what have you, and just break it into pieces, and then we can make an API on top of it, done. Which gives you sort of this model of the world. Instead of having these triangles representing a file, they just represent objects, and you do something with a header, you sort of figure these things out. But there's a but there, which is basically the actual problem we have is it's not only that they're individual objects that we need to transact, it's actually different groups of people own different parts of the same objects. So we have this, light fixture example is a very good one because it fits a lot of categories, but there's nearly every domain has multiple owners. Even if you think design, construction, maintenance, those are three. But then you add on like, this simple one, like an architect might identify a location, a lighting designer, sort of performance, the electrical engineer or a low power engineer. Somebody's got to procure it, somebody's got to install it, somebody's got to maintain it. And then, oh, by the way, these could happen at the same time. People operate airports that work this way. So you have to think about this particular problem, and this whole just turn IFC into a bunch of objects doesn't really solve this problem. So then you go to a sort of, this is sort of seeing what was happening with USD early on. So USD is universal scene description. It's becoming a very big deal in the VFX world. NVIDIA is putting it connected to every piece of software in the world. Basically, they're saying duplicates are fine. We just have a system by which you can express what's important. So what's on the screen is, I'm going to just walk over here and, well, I won't point, but you can see like there's two openings, and you just say, well, actually, this is the one that matters. Suppress that one and express that one. So this is sort of how, at a very poor man's detail view of the world, how you could solve this exact problem, staying with STEP, staying in IFC. You could do this by breaking into pieces, and you just have a bunch of duplicates, and you just have to keep track of all the things you care about. Express the ones, oh, if I want to go buy something, use that one, not this one. Very possible. By the way, ask questions anytime. This is going to be a lot of me talking to myself if you don't ask questions or have opinions or any of these things. Sure.
Thank you.
Unfortunately, online they won't be able to see it, but well, oh, you can't use them on screens. Never mind. Oh, don't worry about it. Nobody online can see them either. So actually, technically, I probably have a laser pointer in PowerPoint, right? If it matters, I'll use it. Questions about this? So this is basically the break off IFC into pieces, publish a bunch of overlapping stuff, and then try to figure out how to take the bits you want when you need them. Make sense?
Pieces is like one object per file. Yeah.
One object per something. Posse's asking, is pieces one object per file, and it's whatever the container is, it's one object addressable individually.
Yeah.
Okay. And then you could put a sort of workflow around this. I come from the building side of things, so the actual first buildingSMART meeting I went to was in Singapore, and I was trying to get a MVD created for facades because we don't have a good one in buildingSMART. So I'll work on this, and I still come back to that. So you could come up with a sort of a workflow around this idea that you could package information, we could have transactions, all the ideas that are there, but it's problematic for the next reason. Just go through this. So if you do get the benefit of being able to think, Git is going to come up in the conversation today. This is how some people want to think about this problem. You get to think in pieces, which makes it much more trackable, auditable. Change detection becomes possible. I don't need to use owner history. I can actually just use the file itself. But there's a second but, which is, so from a workflow perspective, actually, I'm going to skip this one because I have it coming up later. Oh, Jesus. There's this, oh, good, the animations work. There's this need to connect a bunch of data that isn't necessarily ours as in buildingSMARTs. So the idea that we need to start thinking about workflow and continuity of data, not just, sort of the step data that we have today. And if you play this forward, you have the same constraints, but you have many different representations. Jesus, the animations I put in here. But we have this world, which is, it's a BIM world, it's a geospatial world, it's a sort of, power, all these other things, ports, all have their different representations. buildingSMART's going through the effort of, defining how we sort of represent, things like alignment. But, we still stumble with point clouds and how to do sort of voxel data or whatever representations we want to look like for the Earth itself. All these other things, we don't have a good representation, and making a single format to rule them all is not going to solve this problem. So really what we have is like going from a big IFC file to a bunch of little pieces of IFC to, well, actually it's not IFC at all. Or it's 50% IFC at some percentage. So we have to think about how we actually stitch all this stuff together. How do I make workflows? This is actually something, if we need a break from me, I've talked to Tom. He's going to talk through a ledger discussion about how the system we're talking about today might work in that. Just some prototyping he's doing, but a whole bunch of sort of connected workflows have to come out of this. Not just I have a data set, point in time, throw it over the fence, done, which is sort of what we're at today. So what you end up with is, I always forget when I steal slides from old presentations, I forgot to have this is some sort of do it again sort of life cycle diagram. So we have, sort of this sort of view of the world, which is, if you were to try to solve this problem by making IFC the thing you put everything else in, I don't know about you, but I have been in a standards organization long enough to understand that, people want their own turf and they want to make my standard. So the idea that we would, sort of be able to talk to the geospatial world, point cloud voxel world, and say, we're going to make a space for you. Just come over here to our side of the world. We'll solve everything for you, is, I think, a stretch. So you need sort of a bridge. And the thing that's come out of the early work is that this bridge is actually the thing you start with. And then we can talk about putting IFC into it and linking the other concepts into it. So it's got a weird name. I apologize. I have to sell these ideas to other people besides this kind of room. But I don't apologize. It's just a weird name. But the project I've been working on this is focused on using star stuff. So Magnetar was the project I would put a name for this thing. So the terminology I'm using this is strange matter, which, if you're a real nerd, is the most stable form of matter inside neutron stars. So it's a topology. It's a protocol we're talking about. It's not a new format, but it's basically just the underlying ideas about how you put the stuff together. This name can go away. We can call it a protocol. We can call it 12 if we want to. I don't care. It had to have a name to separate it out. When you're talking about, it's not IFC we're talking about first. We're talking about how does this protocol work that we put everything in and stitch together, and then we can have how IFC goes in a discussion. So far, so good. So we waffled between, is this well, the early conversations were, is it a meta information model? So you have a governance model, which is how data should be used. You have a data model, which is how you put data in a storage mechanism. And an information model is the sort of middle ground. And so we're starting to say this is a meta information model because it's basically describing how you put a bunch of data together. So good word, but it's also confusing. So protocol is the one that's come up recently that people like. And protocol simply means it's, a file is a protocol. TCP is a protocol. They're complete. So they have an end and a beginning. Whereas if I said this was an API discussion, you could have a singular view, whereas the protocol view is just sort of say, all of this is included. And that's why this is an important concept to have. We'll get into what this means. So this is basically just saying, oh, well, this is how the web solved this problem. Maybe we have a similar problem with the web that you separate sort of transport from applications. So IFC being an application in our example, GIS being an application. If you think about what we're going to be proposing here with an entity component system kind of approach, it's this transport layer that connects everything together. And then we put the sort of application layer on top. And then the other important aspect is storage is separate. This is a little, like if you don't know the TCP layer stack story, this can be a little confusing, but basically they said, you don't solve everything by making one protocol that does everything. You build it up in layers and you add to it over time so you can make new protocols, make new apps. Like the reason the World Wide Web exists is because somebody made a new application layer on top of the internet, right? It wasn't because they invented the internet. Makes sense at all? I mean, I haven't told you much yet, just that we're talking about this level. Okay. So basically what we've sort of arrived at is what we need is a component-based approach. And I'll sort of deconstruct this in a second. But basically that if we think about putting all the data we might care about, which some could be proprietary data, some could be open, and you sort of develop a system, this protocol, where you can put these things together, you can start to open up the world for new standards to work together. So, or existing standards. So like the perfect ones here are like, you can immediately put the 3 buildingSMART standards. This is why I knew you had a logo. I had to look for it. You can put them together and actually connect them together so they're not floating around independently in space, but they're actually sort of part of a whole. So I'm going to go skip ahead a little bit. And then we'll walk through some of the sort of schema that starts to describe these things. So really what we're doing is we're starting with, I'm missing a slide. That's why I'm confused right now. It's not actually missing because I have it like 10 times, but I'll have to go backwards in my deck. Apologize. Yeah, this is the one I wanted. So what we're really doing is something like this. So we're taking an object, we're splitting into pieces, and the term entity component system is something that you should know if you really want to get into this, but I'm not going to dwell on it because it's really a model for what we're describing here. So entity being the generic concept that we're describing. So what you see on the screen is in a traditional object-based oriented approach, you sort of have a single object. So we have a wall, it's got p-sets associated with it. Like it's a thing in IFC. It's actually modular in the definition, but we treat it as it's a whole. You know, if you export a wall, you get the whole thing, and all the p-sets and so forth. But if you move to an entity component model, so entity just becomes an ID. So it's just the descriptor of a thing, and then you can use a compositional model to say, oh, I want to describe this column in a bridge, let's say, with some IFC geometry, some p-sets. Oh, it's got a GIS representation. This is an old slide, so it's got this German pipe automation logic doesn't make any sense here, but you get the idea. You can associate maintenance data, but the key thing is these are totally independent. They don't have to be next to each other. They can arrive at any point in time. The fundamental idea, though, is that this sort of general approach allows flexibility that we don't have today to solve this sort of fundamental problem. I got to go back in my deck.
Okay, it's fine with the needs.
So this approach introduces a bunch of sort of new things we have to think about, which is to say, okay, I'm taking today what we think about as a single object, like buildingSMART describes, you know, sort of a IFC wall p-sets, the relations those things have. What you're saying is that I don't know, what 700 or something entities we have right now, I think, maybe more. Someone knows. A little over 700. Potentially, if you start to think about it in a component model, you could have thousands. So part of this process is to come and think about how do you actually start to describe these things so you can bring them together in a meaningful way. So what I'm showing on the screen is this idea that just like the BSD today, you can have a centralized authority that holds all the definitions for these things. You have the, my company, my project, my country localization. We have to replace the type. So like we have a canonical my wall isn't my wall anymore because it's broken in these pieces. So we will talk about this archetype idea. And then finally, you have to distribute this stuff. So perfect example, it's always good to start with simple stuff. Like it could be in a lot of scenarios that, that IFC thinks about a chair and maybe, I think IFC maybe covers like 5 or 6 of these on the screen, these little buckets, these little components we'll talk about. But the full sort of owner view of this chair might look like all these things. So this is the sort of problem space we're opening up, but we have to think about how we solve. So let's jump to the web and actually start to talk through what these things are. So I've started to go through and document all this stuff. I don't think I need this one, but capturing all these requirements, I'll send this out, but Greg needs to do a really good spell check and grammar check on this thing before you get the links for that. But we'll go here. So what are the pieces of this sort of solution? Okay, is that big enough or we can go bigger? Okay. So we started with this idea of an entity, which is really just an ID, sort of, it's a UUID. In going through this discussion, we've sort of were pointed to the idea that one of the things that is sort of happening in the UUID space, which, there's a space clearly, is the UUID 7 standard introduces a consistent GUID, but it also helps you with time. So they're also they're both unique, but they're also ordered in time, which is a sort of nice thing to have as a starting point. That's how we're illustrating this. None of this actually, this is open if you want to follow along on the web. I just haven't shared the links. You can follow it at the top there. This is the time, the sort of at the entity level, the first one wins. This is sort of a model we'll talk about. Like something has to create an entity the first time. So like if I have 50 components, the first component, and this is sort of a unique variant of how this approach, the first component makes the entity. And so at this level, the entity UUID is the creation unique identifier in time of the entity.
So it's about when it's defined, about when it's created, but not when it's defined?
At the instance level, yeah. So you're asking exactly the right questions. We need a definition, and then we actually, on the instance data, need these UUIDs. So we'll walk through exactly that.
Okay.
So one of the things that some of the other entity component system approaches say is everything's an entity. Actually, a lot of if you've watched in the recordings from Montreal, we had Autodesk, Trimble, and Bentley. Bentley, not so much on the entity component system model, but we also, since then, I can't talk about them publicly, we've learned 2 other major vendors have started to go down this path because, a composition model, I have 10 tools, putting those 10 tools together and is much easier versus trying to come up with a uber internal format that solves everything. So it's not an invention that buildingSMART is inventing from scratch. It's something that's happening. But if you want to solve the distributed ownership problem, you do have to make everything a component where the entity is an ID. It's not really owned by anyone. It's a different concept in a traditional system where if I had a database that had all the entities might know about all their components. We have to flip that around. We'll talk through that. But that's why in this system, everything becomes a component. Go ahead.
There's a question and a comment in the chat. The comment has just been posted, so maybe it's already been answered. Christian's just put a thumbs up. But there was a comment as well. In order to move closer to the digital world, we believe it's important how to technically link not only static data, but also dynamic data with IFC.
Yeah, I mean, this system could care less what the data is. That's sort of the point of doing a system like this is someone has a use case, it needs to be supported. It's independent of that discussion. The component could be a pointer to a URI, and that endpoint could be dynamic data. We'll talk about exactly that stuff.
The short question was, will an asset administration shell for IFC be a solution?
Asset administration shell. I don't actually know what that means.
There's more context. The purpose of an asset administration shell is to bridge the gap between the physical world of industrial assets, such as machines, equipment, products, and the digital world where information about these objects is stored and exchanged. It enables the unique identification of objects, representation of their properties, states, relationships with other objects, and more.
I mean, it sounds good. I will say this is intentionally not trying to solve a problem. It's trying to solve a generic problem. So we'll probably find overlap of things that have solved it this way. I mean, like I've already pointed out, that overlap with the TCP approach, like separation of concerns, like the whole dynamic data. I don't think I should have to care. I think people with dynamic data should care. We should have thought about, can it work? Yes. Does it might need a separate storage approach? Yes. Does that break the system? Hopefully not. There's, Angel's got his hand up. Where's a?
Trying to understand here, and sorry if I'm skipping ahead 75 slides or something. Are you suggesting, okay, as you said, there are a number of groups that are already kind of looking at component-based architectures, right?
Yep.
Are you suggesting that this is a different component-based architecture, or that here's how IFC would fit into any component-based architecture, or here's the minimum requirements of it if it did?
So the minor nuance that, so it actually, if you look around, most of the time when you find ECS systems in documentation, you'll find software libraries. Some of them, most of them come from the gaming world. This is a 2010 era thing where this starts to show up in the C++ world. The early ones, the entity always owned and kept track of the components. So I'm running a game, I break off my player character's texture from their geometry, from their collision, and I can sort of monitor those, but the entity always keeps track. There are some later versions that actually says, well, that's actually a lot of overhead, so the entity shouldn't have to know. And so the components just know where the entity is, and you can do it the opposite way. So the only nuance we're saying is, to solve the distributed problem, we have to take, from a data perspective, the latter, whereas the component points to the entity. The entities don't know where the components are. Because I, as a design firm, could have separate data about the entity from a contractor, so clearly the entity can't know across that boundary. So that's the only difference. So it's an implementation detail. It's just depending on which reference you find for an entity component system. Autodesk's documentation says that everything's a entity. I don't think it really matters. I'm just making the clarification that we have to make this small adoption of the components know the entity just doesn't know the component to make the system work in this domain.
Okay.
Questions from anybody else? Thought I saw a hand. So let's talk about a component. So,
So, but what you just said puzzles me. So, but there must be some level of orchestration of all the components.
Oh yeah, you have to replace files and all these other things to make transactions make sense. Yeah, we will get there. But yeah, because if you just have these things floating around, orchestration becomes hard. But okay, so let's start defining one of these things so we can talk about in the breaking object into pieces problem, this is sort of where you're going. Like when you make these small chunks of data and they could just conceptually float around, you have to make them much richer in, well, what am I? Where did I come from? Where's my definition? If somebody finds me on the street, do they know what to do with me? You have to sort of start to describe this stuff as part of the component, because we're basically saying we no longer have like a big file header that says, oh, all my measurements are this, I'm part of this project, all this stuff. You have to sort of make sure we carry around enough information. So it actually, we'll get to a discussion maybe today, maybe in weeks from now about, this really loves things that compress a lot of boilerplate stuff, because components will have a lot of boilerplate on them. Just happens to be the case of what you're going to have to do. So the first thing I need is context. So what I'm not sold on, and I'm not an author of JSON LD all the time, but this is what ChatGPT says, and it validates. I couldn't have Devin from Trimble help me do these in the last couple days to get this stuff in here. We've moved it over from JSON, just the way it's been written. But basically I need a sort of a context that says, well, where did I come from? Which is sort of the basics, and that's just part of the JSON LD definition. What we start to go down is sort of basically what we see happening on the BSDD side of the world, sort of moving closer to the component in what we're explaining here. Basically, the idea is that this component definition on the instance data has to carry around enough information so you can look up what it is. So if you see here, I get sort of a definition, a URI. I don't know how to negotiate which one we should care and focus on URIs versus GUIDs or both. Like the language discussion make me think, well, why don't we have GUIDs for URIs, then we don't have to have English. I don't want to have that conversation either. So I'm just showing both. Someone else smarter than me can make the case in the future which one we should land on if we do need both. We need version information about the definition itself. So this is describing the actual component. I then have to move on to the next sort of bit of information, which is the instance data itself. So think about what's in an IFC header. What application did I come from? What version of the model did I come from? Well, if we're talking about objects, I need that. Plus, it would be dumb not to carry around, well, what's the version of the object I came from? So what you have here is sort of source context. You have things like a file version ID. I'm in the definitions, I say file or file-like. Obviously, file is not necessarily the place we have to think, but the item ID, the item version ID, and then we need to think about, well, you might want to carry around other stuff. So basically at this point, we know what I am, who defined this component, and then this chunk basically says, what's my source data? What am I based on? Unless somebody really wants to change IFC into an application format, which I don't think anyone does, we're going to be published data to some level of form. So this is just an evolution of the idea that I have to keep track of where I came from. Make sense? Heads nod. It's good. Anybody confused? You're confused? No. Go ahead.
I'm not sure if it makes sense, but can I think of it as in software development as well, like objects that you can inherit from and kind of way?
So I think that there's a very interesting discussion that's probably not made into the slides, but is in the text of these are probably just classes generically. The inheritance side, I think that's up to you. It probably doesn't want to show up in the data. One of the I think challenges of a system, well, somewhat on IFC, but like the idea that the class structure is a maintenance mechanism, right? Today, IFC is so complex because we inherit from root. Why does this, like, this is a maintenance methodology. It has nothing to do with the actual instance data. So you could have a object-based system and all these inheritance, and that's how you generate component definitions. I think that should be shielded from the user entirely. I shouldn't have to know, or it should never affect me that, you know, all my wall classes property sets are inherited from one. Good idea, but I don't think we should expose that to the end user.
Great. So really, what's important here is you're defining information that it should be easy to get.
It's in the header, yeah. So it's easy to get to on the object. Yeah, everything we're talking about is header information at this point.
But I mean, what I'm saying is, you don't actually really care how it's stored in someone's system.
Yeah, I'm showing you this in, well, this is a definition, so I'm pointing to what people have said is probably like a JSON LD is good for this definition side of things. On the instance side, it's a protocol. If you can store everything, put it wherever you want. That's it. We have to mitigate this. It can work in the web. It can work in a file. So by making these small chunks of data, it can work in a lot of technologies. We'll talk about relationships as we move forward. They have to look very similar. But yeah, none of this has to, I have to show you it some way. I can't show you in a database, but I don't really care how it's stored.
Yeah, okay. That's what I figured. Thanks.
Yeah, this is the protocol versus API discussion. What somebody could, if we didn't have a standard API that you could just return one of these, well, this is useless, right? But if you return the sort of component instance data source, most of not all of these are required properties to make a whole thing. Okay, so let's talk about the instance header. So once we have where I came from, what my source data is, I need to describe what I am, what are my IDs, what does a person call me, these sort of things. Some of these are probably not good ideas right now, but I've just basically collected the kitchen sink of things we thought we needed to think about, put them in the definitions, and then we can have a discussion about pruning them.
Guy? Yeah, sorry. So if I understand correctly, all the components here would be like independent in comparison with the inheritance that we have with the root of the other IFC product. So all the components that we would have for each product would be independent for.
At this level, this doesn't even care you're putting an IFC in it. This is really just a component that says I'm a thing. Clearly, what we'll get to is putting an IFC in it. I mean, if you just described a wall, what does IFC product do for us? Like this is where I'm making the distinction. Like our very deep inheritance model is a maintenance mechanism, but somehow it's reflected in our data. Why? Like, why is IFC product a thing anybody has to know? I mean, you have to know it because of what our implementation express and how you get how developers have to touch it. But IFC product is a, 3 levels above and 4 below root, something like this. I mean, I'm guessing because I don't really know. But so it's a question for the room. I mean, clearly, like as someone looking at with, a fresh view of the world, if components have definitions and we have to maintain them, that's fine. And we have an inheritance model that helps us do that. But I'm not certain why IFC product and root and element and all these things have any bearing on the data itself. Unless anybody's got a good reason why. Tom?
Yeah, thanks. I don't know if it's good reason, but it's nice if you have like a bunch of different beams, you want it to be different components, maybe you can loop over all of them, like basic polymorphism type stuff.
Oh, absolutely.
So
but
as long as that's in there.
Well, that's a maintenance concept though, right? I mean, that's how I maintain all the beams, but in the instance data, unless we're trying to do, you get your properties from this generic concept and then you, that gets confusing to have to think about that even. Like,
well, you know, it's just composition. It doesn't have to be inheritance. It's not functional.
yeah. And so yeah, I think basically what this discussion points to is like inheritance and polymorphism makes, I'm using words I know, I don't use them myself. So, but makes perfect sense on the maintenance of the stuff and the generation and the sort of, I don't have to have independent classes floating around. On the instance data, it's sort of confusing why it needs to be there.
Yeah, I mean, I understand that right now we're talking about a generic system, right? But to your point, eventually we'll want to come up with, here's why you'd use it.
Yeah.
Right. And at that point, then you do start thinking about, well, how do we optimize for the queries that we're going to make, right?
Yeah.
Do you want all the beams? Do you want all the quote unquote products? You know?
Yeah. So, I mean, everybody would say that the maximum depth you want is 3, right? Versus 8.
Sure.
That's the discussion. And is that just a name spacing exercise? Maybe that's all it is, right?
Yeah. Yeah. Like I said, I'm not leading the conversation anyway, right? The point is that the users are the ones who are going to come up with the queries that we're going to have to optimize, and that should let us know how we structure this.
Yeah. Yeah. So we'll have to come up with a ton of components. Those components will probably want to be something like the point, like how you query something, and these things make sense. But is it like a namespace, or is it all these other simpler methodologies of doing just that?
Yeah, thanks.
Okay. So basically at this point, if you would keep going, the stuff that you might find questionable. So let's just talk this again. So this is the first place we see an entity GUID, which is to say, if this is the first one, I make this component makes it, but that's clearly you carry around the component GUID and the entity that you're referencing. You have, the idea that you might want a human readable. I'm using the word semantic, but I actually think this is more of a human readable version there. You have a version GUID. There are 2 very distinct sort of early on, we were having this discussion. It was thought of as this stuff is immutable. It's only copy on write. You never update. There's a part of the world that really wants to look at this in a sort of, we could use Git-like approaches for something like this because I'm treating individual smaller chunks of data. If the geometry isn't binary, it's actually would work pretty well. So there's a late add here that we can fight on as a version increment. So if I haven't published a bit of data, it's on a version. Again, these are just some of these are just placeholders for things that need to be figured out. Can I increment the version without changing the major version? It's just whether you're overwriting or not. That's more of you shouldn't overwrite components coming from a different piece of software. That sort of stuff we'll need to think about. Sequences. There are definitely scenarios where components have an order. Angel has brought up in previous discussions ideas that one piece of geometry derives the next. So in this system, you can have 10 pieces of geometry on something. If you want to impart an order or a sequence that one derives the next, you can do that with a relationship. We have a little diagram of that. Or you could just have a sequence. If you're thinking about longer lists of textual data that you want to associate as components, like I want to put inspection criteria as a link into this thing. Well, step 1, step 2, step 3, that's sequences. It's why it's there. Is it the right way to do it? Don't know. But we sort of have to think through it at least. And then there's some basic, option status. That's, but you do have to think about whether, I think from a very slim perspective, we do have to understand whether it's work in progress or active. And then you have to say whether it's, this is duplicative. So this is basically how you could do it two ways. Or it's actually, I'm not deleting the data, but I'm no longer active. So this component doesn't exist anymore. So stuff, again, has to be worked out in detail, but this is the sort of stuff we have to address, but it seems to make sense. Okay, so now we know what I am, the definition, where I came from, the versions of information, but then we get into like what's the actual data I'm carrying around. All right, I can show you examples of these payloads in a second. But really it's, well, what do I need to generically describe the data I'm pointing to? So again, you want to be able to ask questions quickly of the header and not have to touch the data itself to understand it. So things like, is there a payload specific hash? I'll show examples of that. And if you're just doing a reference, it's just like a SHA-1 hash of, well, that's the thing I'm pointing to. So if I iterate the component, I know if the data is the same data I'm pointing to in the component. What's the data type? What's the encoding? These things. This is much simpler to look at if I just show you an example. And then we get into sort of a relationship. And these are, I'll maybe come back to these. Let me show you payload examples for questions. So the first three things are just, where did I come from? What software that made me, and what version ID entity am I? Payload is where the data sits, right? And that can be pointed to externally. If in this example, if it's JSON data, it makes sense to just put the JSON in it. But here's just a dumb example where if we did just break IFC as is today into small files, just reference them this way. So basically I put a overhead over it. This is basically just pointing to a slab. So the payload data is really just a URI. And so basically you put an organizational structure on top of it and I can point to them. It's a lot of overhead for that, but it's a relatively simple approach and wouldn't be hard to implement today. You have a lot of duplicative headers in these files if you did nothing, but you could do it. So far, so good? You're thinking. Okay. So we should not think about this just as geometry. It's easy to just do that, but clearly, if I can make a relationship with two things, I want to make a relationship between things that are relevant, so a requirement. So just a payload. None of this is geometry specific. One of the things you'll find is a lot of these USD, the Open Geospatial Alliance is trying to make, or consortium, Open Geospatial Consortium is trying to make a sort of a collector format for all their formats. They tend to be very specific to geometry. Our world is geometry plus a bunch of other stuff. So this protocol approach has to point to a lot of things and not bias any one of them. We can certainly have a discussion about optimization. But if you're, just taking advantage of, well, maybe we use a JSON representation for these things until we decide there's a better, somebody wants proto buffs, whatever, I don't care, but someone will say so. You can just directly use GeoJSON in it, right? Oh, here's my site, GeoJSON, it's not IFC, I can just put them together directly with a relationship. And they can actually be on the same entity. The first implementation we'll probably do, and so far at the low end of geometry representation, I just need triangles to make it display. There's broad agreement that GLTF is just fine. Why not have a GLTF representation that can sit next to the other representations? It solves visualization, but again, these are basically describing the, similar or same object. Do I have this in twice? Yes, I do. Oh, wait. Yeah. And it's always just good to have other dumb examples, but I want to include an image of the site. I mean, again, this is supposed to be a flexible approach to connecting data that describes the same thing. Clearly not showing all the whatever 64 base 64 encoding this is. I've just left it all off. Yep.
How about if you have things that like point to entities, for example, like a BCF topic. So it's like,
Yes. Let's actually show one of these, because one of the perfect examples of so I don't necessarily a topic, but Tom works for a company that works on clash detection tools. And so one of the perfect things you see all the way, I'll show at the bottom here, sort of, is what about something like this? So it's not a topic, but a clash is a stand-in for a topic. Today, I make a topic that's independent of the data itself. This approach allows you to just make a new component that is a clash or a topic or one of these things. And so it points to, we want to make these other kinds of relationships that are useful between the data that we can't, because our data representation boundary doesn't make sense. Like, it doesn't make sense to put clashes in IFCs because it's for geometry and description. But if you move relationships outside, you can do something like this. I can have two components. I can clash them, and I say, I'm not going to modify the two components. I can now make a clash relationship between them.
The class relationship, that's pointing to, so one component is pointing to the relationship, and the relationship is pointing to another component.
So this is where arrow etiquette doesn't follow. Basically, the way relationships are set up is relationships point to the components. Components don't point to the relationships. So a relationship is completely self-contained. It has a source and a destination.
That makes sense. Relationship points to components. Yeah. So where does how can I find the relationships then? Like, where are they hanging? Like, if they point to the components and components don't point back.
Right. So basically, we don't have inverses in this scenario.
Yeah. So I understand that. But if I want to list all the classes of the project, for example, then how can I find it?
Well, so this is where you get into, do I make more unique relationships? Because then I could just query clash relationships, and that would give me all the components, right? Because they would have an array on either side of all the clashing components.
But is relationship, is that an entity?
Yeah, first everything's a component. So we can go through the header of that, but yeah, exactly. It is just like another component.
But is relationship, is it an entity or a component?
Well, everything is a component, but so by being in existence, it has an entity. That's just this is just generically how this approach works.
So,
but
I assume like the clash results, I guess, could be an entity that all of these relationships would have as their entity. So you might say, give me all of the clashes related to this run. Is that?
Yeah, I should have just showed it to you. So here's what a component instance relationship starts to look like. I have source entities. So some of these are, I will say, quality of life things that probably sometimes might not make sense. So the idea that I carry around the source entity and the component, it's a little illogical, but sometimes I only have one piece of geometry. I would just want to relate to the entity. I have no other representation. It's just simple. I want to think about entities, so I think about the source entity. If I have 5 pieces of geometry, I want to say which one do I clash with. So then I want to say that component, right? So the relationship has both sides of that. And so basically I have source entities, source components. This source type thing is
redundant, maybe
iffy, but you might want to say, I only want things that clash that are beams. This is me just thinking ahead to how this is slightly harder to query. So I've been told several times after I put this in there that we should just we'll solve the optimization part after this. So you can sort of negate that being there right now. But fundamentally, you just get to this point where you have arrays of the components and entities. I'm a relationship that is clashes with this rule relationship. And I have either sides, and one of the things you realize is all the stuff that we want to describe, most of it is relationships. How far you want to go down the road of making custom relationships, is type is a very one we'll show an example, but is clash on my component based on Steve's requirement last week relationship?
Is this one to many? So do you have one source and many destination, or?
Yeah, and this
it's components, so it's a plural, so it's many to many.
Yeah, it can be. Well, yeah, and your many can be one. So in a typed relationship, I have one thing that points to many, but yeah, it could be many to many.
Yeah. Yeah, I'm just thinking. Okay, so if you let's take so this is a clash relationship. So if you take BCF topic, would that be a component or entity?
BCF topic would be a component with an entity. It would be
okay. It is
separate. I think it's a separate object, right? Yeah. I have a piece of geometry and I have a topic.
Okay. Good. Okay, then it makes sense. Okay, thanks.
Yep. No, so let's go back to actually that example, because one of the reasons, one of the, I'll just call it shortcomings of BCF or this clash workflow is we're not set up to make any sort of optimization. So let's keep talking through that, because it's a good example. And frankly, I like Tom to care about stuff, and this is one that he liked. So I have the sort of component clash. You could make the sort of custom relationship that says, oh, this is a routing error clash, right? Again, it's just like any other component I can sort of make. I could actually say I can associate a resolution mechanism, so I could make how to fix it relationship. I'm not saying these are good ideas. I'm just saying this is a sort of why this system is flexible. Or you could get to the point where I can actually sort of associate the fixing with an algorithm that can inform me how to fixing. But fundamentally, this easily creating of relationships outside of the data itself is one of the more compelling reasons to do this, because of pretty much everything we talk about in our industry is just more relationships that we can't capture natively in the data itself. And this is how you make it machine readable. You clearly still need that whole header that says, well, what's my definition if I'm making this relationship? We don't want a bunch of on the fly, Steve's relationship, because that wouldn't really solve a problem if you didn't know the definitions. But we start to treat them like things you define just as you describe components. It's pretty powerful.
Great. I think, yeah. Sorry.
No.
I think you said that the relationship would only point to the components, but the components do not point to the relationship. So it would not be circular as you shown it, but it would be bottom up or top down, the way it is presented.
Could it be?
In IFC, relationships for the components.
Yeah, and actually, we'll get through how we got to how you point, because we're doing this in pieces. But this approach allows you. This was Tom's insight after Realm, we figured out that if you do component to component relationships, you can reverse engineer IFC today into the system. Okay, so let's go back to slides because everybody wants more slides. Questions so far? So we've like gone through the mechanics. We've gone through like what a component is. We started to talk about relationships and how we got there, but we'll go a little bit detail. What I want to do is walk through how this thing is proposed to be used, because that's the reason to do this stuff, right? And you guys tell me when we should take breaks. Breaks? What time is it?
Another half an hour would be about halfway through the morning. But open to have a discussion.
Okay, I'm gonna keep going.
I have a question about the word component. Is it a type which is not which have not an instance, or is it an instantiated type, or both?
The language is messy, so that's why I've like in the definitions I've started to sort of the definition of a component versus the instance of a component. So components are definitely typical, as in I would have many of the same. Like if I have a wall component, it is very. This is where a software developer would have much more finite language in making these separations, but I think it's closer to a class.
My question is because you have a relationship between components. Relationship you only can have between instances normally.
Yeah, but that's the benefit of this kind of system is they can actually happen between types, and you can associate instances later.
Okay, then it's both. Types and
because you can use relationships to say, well, I use that component's geometry. I've essentially made a mechanism for having types, for grouping. So
yeah, a component is agnostic to instance versus type. It doesn't matter. The component is agnostic to instance versus type, right? A component can have data that's specific to an instance of something, or it could have data that's related to a type that many instances would
use.
Yeah,
I mean, let's just, because you're asking a question, let's just jump. So I have to make examples for different groups of people. So, a lot of architects use Rhino and Revit. So this is just talking through, this is very US centric, but the architects I talk to, like, okay, I have a Rhino facade and a Revit structure. So facade is very typical. So what I have is on the left is it'll show up at the end, but that's sort of the repeating information that all these things share, like all the, what does it say? All the frames share. I'm inventing a class because we need one called a frame. We don't have one. Plate and members isn't enough. So I have classification and I have geometry on one side, and I'm just doing a simple mesh. On the other side, I have all the instances, and all they have is a location component. So we're using type of to make a relationship to say the stuff on the left is repeated several times to describe the stuff on the right.
Okay.
But I mean, just to play this forward, let's say stuff that isn't so typical. And this is the reason I have these slides in here, because we have to go through the type, map, group, grossness that is IFC to clean this up. And this is the kind of stuff, the flexibility that we need to address. Because on this example, I'm sort of saying, well, actually, there's very little repeating geometry. So I move that to the sort of all the typical ones, but it's still a relation. This is a little nuanced to model. And this is sort of, it becomes wide open, and then we have to put constraints around what you can do. And this is clearly an implementation thing that we have to put clear constraints. Like you can't just do any of these things, because otherwise we're back where we had an IFC that you can Oh, you can make a relationship to root. I don't think you can, but this is stuff we have to constrain. Does that make sense?
Okay, thank you.
But to the question, the reason I did this one, and I mentioned this to Lars at dinner last night, is what if you wanted to do, well, we're talking about use cases, so I'll go back one slide. Oh, it's in black text, but on the top it says type in instances. I don't know why it's not showing up. This demo is actually pointing out one of the key reasons to do this from a functionality standpoint, which is I can assemble and add to data externally versus having to take ownership in an individual application. So you can imagine this is a 3 application triangle. So these are the 2 that make the geometry, but everybody wants to solve carbon right now, right? So the idea that I can have the gray circles are just relationships in here because I didn't want to make up new names that I didn't want to have to defend. They're basically just saying, well, I have a material entity that has the carbon info as a component. It's got, there's at least 4 parts of a material definition. But one of them I'm showing here is just the sort of carbon part. And I'm making a relationship to these frames. So this is interesting, but it's doable today. You do this outside. But the big difference here is right now, most workflows you have to get this geometry in one tool before you can do this versus I can put it independently outside. But the real benefit of a system like this is actually I can make entities that are library entities that I can reuse before the instances exist. So I can have a library that, I just have something watching this data. The second I see it, I make these. That's interesting. But if you play this ahead, this is just what tooling you might need in tools to make this consistent. Well, I can actually have low, medium, high carbon components for this material. And instead of just getting one result, I can get 10 because I can carry around more than one. So the idea that I do the same thing and I can get, sort of that continuously because you can assemble it outside is sort of a major sort of use case of this approach. Whether this one particularly gets ever built or people care about it is not important, but the sort of external assembly additive workflow, like the code builder example where you guys are using owner history, this should just be happening. Oh, well, I see those. I make a relationship with the components exists. I've added to the data, done. It's how it should work. Okay. So we're going to go back a little bit in time. The question is a good question, but we'll show a simpler example first because there's one other big thing that will come through on the software side. So let's actually make this. So I think there's a conversation to be had, but I think, and Tom and I have started the conversation but never finished it, so I don't know where you stand on it. But I think you need one component that you always have. And this is sort of the most generic one. Right now, it's just called the ID component, which is if I want to make an entity, so say I have a CAD tool, say I'm CATIA, and I make a slab, and I want to publish it. Well, I can publish it all at once, or I can do it, sort of over time. The geometry is not changing, so I just want to make it exist. One of the questions is, do you allow the first one to be any component? Like, oh, the geometry's first, so it makes the entity. Or do you make this first one? The only sort of practical reason to think about this is if you ever want a user to be able to figure out what it is, you might need this ID component, which is sort of the equivalent of identity data in ISC today, which is, oh, I call it slab. I give it number 2. that is generic across whatever data you put in here. So that's the logic about having a sort of a single component. That's the first component. It's a solution to the potential problem, but I'm not certain it's a necessary one. So really, what that's saying is, actually, let me get to this other discussion. So, coming out of Rome, I think we had someone like what's David's last name? Yeah, David Koenig from Arup kept telling me, and I'm sort of dense, so it takes me a while to hear things, that you don't really need the entity. And like, well, what do you mean? Because I kept drawing them like this, but I was like, oh, the entity has the ID and it sort of has this stuff on it. But of course, if you want to make this ownerless, you can't put any sort of owned information on the entity. So what actually became pretty clear is this, like, well, if the first component makes the entity, you don't need the entity. And so it becomes virtual in the way I'm describing it here, because it is a named thing, but it doesn't really exist. Probably in some storage technology, you'd want to objectify it so you can make joins to it if you put it in a SQL database or something like that. But in the sort of native representation, you wouldn't think about it that way. Because you really just need the components. You really don't need an entity. The entity is just a number, unique ID.
You need the ID.
Well, you need the ID, but if I'm first, I just make the entity ID. It's just like the first.
That's the ID.
Yeah, it's just the ID. That's all it is. Yeah. So.
Can you go back a second to the slide? So it says entity of type wall.
Oh yeah, so this is the dumb Greg's dense doesn't understand, because like, okay, I need something to identify this thing. This is post Rome 5 months ago, 6 months ago. I didn't understand this. Well, you don't really need the entity concept. So this was a first pass that's wrong.
Well, maybe it's wrong, maybe it's not, because
it does could have a classification.
It does have, exactly. It does have this idea of,
is it helpful?
What is it? And it's in some sense authoritative.
Right, but you don't have anything with this thing. You actually just have an ID.
Well, you have the type as well.
Well, I have an ID that's a wall.
Well, it says wall though.
Right.
This is literally semantic.
Right.
If you always have an ID, if you always have an ID component, which you do need, right?
Well,
you could call that the entity and
right.
still not have it point to anything else, right? Or you can think of it as a component. I don't think it particularly matters.
But isn't it so that you have, if you go to the next slide, so entity is just a UUID. So it's not a component, it's a UUID. And then you have a component that tells that this is a wall.
Yeah.
Right.
So
wait, and every component would have its classification on it.
Yeah. So then,
because yeah, let's play this out. So we had this request in Boston when we started having this discussion. In the UK, can't remember what the road authority was called. They want to generate 100 signs, give it to the design team, and then they make the data for those signs and give it back. So basically, we want to make the IDs for the signs, put them in their asset management system before the data exists, and get them back. You can do this by making an entity, and here's a list of the entity IDs. Or you could do the exact same thing and make the component with an ID that says, I'm a sign. It is a distinction without a difference. It's just whether this is the most clean approach, because so the only reason I might come back to your camp is to say, I want to tell you something exists, but I don't want to tell you anything about it.
But isn't it like if entity is just an ID, then this thing is like neutral to any technology, so we don't like say that this is an IFC wall, and that might be if you put some other components from say GIS or something else, then they might be authenticated by the IFC wall. So it's better that it's only entity, and then you have components that give the aspects.
Right. So, I mean, you get the same result either way. If I have an ID component, you've named the entity, and I can tell you I have 100 of them. So I have 100 IDs and I have 100 signs. I haven't told you much else about it. Questions over here?
But so an entity can like really still be anything. So it could be a building element,
a banana, yeah.
But it could also be like this kind of relationship, like a clash. It could be a BCF. And so like if you only have the entity, you even don't have a clue whether it's like, you know, a building
you just have a number,
or just a relationship or anything.
Yeah, you just not a number. You just have a string that says yeah. But this
so
is
like your ID component would, for example, at least already distinguish maybe between those concepts.
The notion is it's instead of making an entity, you make the component that's the ID component, and it makes the entity, and then you can, it's sort of the garbage collector concept, because then you could say as much or little as you care about, and it's really just giving it a definition. So it's a generic one that, okay, this is the way to make. If I know nothing more than it exists, but I want to say it's a thing, here's how to describe it.
So basically you just create a component that has a new UUID, and that's the UUID is the entity.
Yeah.
Kind of.
Yeah.
So then if somebody else wants to add more information to that, the same entity, they will refer with the same UUID.
Yep.
So you don't create an entity, you just create a new component with a new UUID.
Yep. Share the multiple components with the same UUID for the entity.
Yeah.
Right. So the only distinction I would make is I think in some sense, right, really, you shouldn't need any, you need a component, right? Because that's has a UUID that makes the entity come to life, right? In theory, you shouldn't need the first component to be anything in particular. The first component could be some data about it, which I don't know what the data is for, right? Because I don't know, but whatever it is, the length is 7, right? I don't know it's a beam. I don't know anything else.
Yeah,
right?
Length 7 could be the first component,
right?
Certainly, but
you can say, look, if we want this to be compatible with IFC, right? We do expect to know what this is, right? The one thing in IFC is we have some classification about what this object is, right? We can't have return length 7 for nothing.
But that's a component. But think that if this is if there is something that kind of in a project that predates the IFC data.
Yeah, and that's what I'm saying. I'm saying I think that's fine. I don't think that I don't think it should be the first component. It should be the required component if you want to get IFC out of it. Like there should be a component which is, if you want this to be compatible with IFC, this component exists and it has this critical information that any IFC in exchange will have, right? Because as you said, you could have a system has the GIS data, it has delivery data, it has blah, blah, blah data. And now, now I'm interested in IFC. So I'm going to tag this with some IFC information. Now I'm going to make the IFC first component, but it might actually be the 30th.
Yeah, and what you're describing might be the right solution. Is it's domain specific what the first component wants to be.
Yeah, so you could have a space program, a requirement for a space, for example.
Right.
So that would be a component that has an identity. And then when the architect creates the space, the IFC space, then that's when the IFC kind of comes to life. It's still the same. It refers to the same UUID.
Right.
But the requirement is before the IFC data.
Yeah, and then it's just a question is like, is that IFC, or are we making a much more simpler requirement language for program, and then that's something else. So, but yeah, absolutely.
Yeah.
You guys are getting the flexibility and point of such a system very quickly, so it's good. Yeah, you can do things out of order, which is sort of nice versus what we have today, which was really can't. So.
Yeah, I mean, I appreciate that you don't have to have a pointed element.
If that's the right way to say it.
Like, if you go back to database design, you have a pointer and you have a pointee, right? You have an ID and you have a pointer to the ID. And you can live with but you need to know when something is a pointer and when something is the identity.
Yeah.
So
well, the identity is, I mean,
so I try and use a different word, but when something is a reference to something else, and when something is its own entity name, right?
Yeah.
So you always have an ID, and then basically you don't have the difference between the entity and the component in a sense, right?
Right.
The same type of, or they sit in the same structures, but you need to have a clear perception of what is pointing to something else and what's the object ID, right?
Well, yeah, the most critical thing is like the entity is the shared concept. All these components describe the space. Some are requirements, some's the geometry, some's the fire rating, some's the door it connects to. No, that's a relationship. Some is like the occupant. If it's all the same concept, it's all the same entity. And
right. I mean, right. In general, this is components. This is a soup full of components, right? So in practice, there does need some way to be able to look through that soup to get the information you want. You don't really want to go through every single thing until you find the piece of information you want, right? So again, that's where the optimization comes in, right? So probably somewhere there's going to be a list of IDs and, here's a quick way to get to these critical components that give you pointers to other things, but that's not required at this level. At this level, we're just putting stuff in.
Okay,
and it's up to someone to figure out how do I quickly query for interesting information.
We still, I mean, just to be clear, we can't end at components from a system like this. You have to have a thing above that collects the components and does what Angel is pointing to. And you need something like that. It just doesn't look like a file that contains the stuff. It just points to the stuff again. So, okay. So we talked about this. And again, maybe like this ID component could be system data type specific, could have that conversation. So I think everybody's grasping on this, header and payload, depending on the serialization, these might be hyperlinks or URIs. I mean, I use hyperlinks as a dumb way of saying URIs. Or it could be, the way you're storing it is actually just fine with storing blobs of data. So binary data, whatever, it's sort of the same record in that technology. It's just separation of concerns. Identification versus payload is an important piece. So one of the other goals that has been dangling out there forever is how you sort of solve design transfer. And this is solving it by not solving design transfer, because don't solve transfer, solve reference. So this is just illustrating a sort of two apps. And again, I come from a background as an end user, so you get end user views of the world sometimes. So this one is basically saying, I skipped this part, but the predecessor of this slide was basically currently moving data between two tools means I have to actually stop using one or live with duplicate data. It's sort of the world. But if I go down this path and I've published, this is where I do need to go back in some slides. I apologize. Break.
Love this example of the chair.
Yep.
So shall we do this one and then have coffee?
Yeah. So let's start one level before, which is I've defined my components. I know what the term for the the superset of all the things you care about that we're using right now is archetype. It's sort of used for this purpose. Because if I don't have a super object that defines all the components, I need a way of some saying, well, this is actually the stuff I care about. So you should think about it that way. Like, what do I have? That I as an owner care about, right? So it's a collection of all the components that exist in the world that I want to provide to someone that's going to give them to me. The mechanics of that provisioning is not in the system, but basically, what the hell? Oh, for some reason, this slide is not hidden. There we go. So in reality, though, like nobody, like we have this distributed ownership problem. Owner requires all these things, but nobody owns them all. So basically you're saying as a predecessor to this, well, I need to say that these components and the creation of the entity belongs to a software, a person, what have you, and that gets created. So then that's where we get, sorry, I'm going to jump ahead where we were. So export out of this tool, chair, the style, location, style being like I'm a lounge chair, location and geometry. So instead of what we're sort of trying to do today, which design transfer is give ownership between two tools, which is a clumsy approach. And again, this is sort of something Angel very much pointed to is don't change ownership, just make a reference. So this is, especially if we have these smaller chunks of data, we can do something like this. So I, as the second application in this chain of tools, wants to do something. So the first thing I do is reference that data. I can make a, depending on the way you look at it, copy, create, or map. This is when, you know, Leif Grunholm always talked about how Tekla would reference an IFC, but then if you wanted to edit it, it actually made its own representation that's linked to the original. This is exactly how Tekla does this today in IFC. Same idea, that you make this new map. So I now have the reference and the new representation, and then I can add some new information. So if you do that, what you end up with is duplication, and duplication outside of a tool is, I think, in my mind, fine, because it's very easy to say, go back to that idea that you can steal from the USD world, is you can just pick the pieces you want. It's so much easier when they're the same components, though. So if you have the component definitions that makes them, oh, I'm getting the same information from two tools, you get to sort of play this forward and actually, well, this is the chair I care about. And then fundamentally, the reason you do this from a sort of distributed ownership standpoint is you can do it exactly what I'm showing on the screen here is one side of this line, and this is sort of an arbitrary contractual boundary. I can share just the components I need to at a certain time as to fulfill a part of a contract, not to be litigious, but people don't share data because they can't control what they share. This gives you precise control of what you do share. And just like before, you could have a sort of new data added because all they need to do is reference that component. You always have to, this odd thing about this, you always have to show the entities to describe the system, but if they don't really exist, it's, you know, if you don't show them, it's confusing. So you get the idea. But yeah, we'll stop there. Questions? Okay. Thanks. Come back in 15 minutes. Okay, let's get started. Now we have to put IFC in this thing. And that's where the real discussion will start, because people will really actually have strong opinions after this point. So, but before we get there, we have to have the file replacement discussion. So let's talk about replacing files. So I think the diagram we'll get to I don't know why I did this order. So logically, we've now made a bunch of components that have data associated with them. They have a bunch of definitions. We know what they are, but we have contractual exchanges. We're an industry that's sort of really litigious, so we want to be able to sort of move this around in a structured set. There are certainly discussions to be had, and if it makes sense, we can have Tom talk about some ledger approaches to this. But at the same time, one of the things we need is to say, okay, I have a set of data I want to communicate to you. It's for a purpose. It's got versions of components in it. So the way that's been described thus far is something like this, where much like the relationships, and I'm showing components here, but we have this term that is bounced around. I think it used to be, first was called scene, then was called composition, and now we're calling it collection. But collection was the best word because it doesn't imply ownership, and that's the key part here. So the distinction between a file versus, if you're a software developer, like a branch in a version control system just points to the resources, like the assets, the files and so forth. And it's a very similar concept here. The collection basically is described as basically an array that stores the components it points to, that includes relationships. This is how you want to, what you want to share, how you want to do it. What is far from really much time spent on is, this is clearly where, if you're doing sort of global coordinate stuff or optimization on storage, because you can think about this is actually a sort of named version. This is sort of an artifact sort of concept. That if I'm making an artifact, I can do some things that are different than the data itself. So I could do some optimization. So all that stuff is, I think, up for discussion. But like I said, the main sort of design of it is meant to look like this, but the original design criteria was this. So the infra world, the building that's next to the railroad for a rail company has a completely different set of relationships than someone at a building would think about. But the big one here is, and this is expressed by David the most clearly from the beginning, is when we're talking about IFC now, and this is, we have to remove hierarchy from IFC, and these are the places you decide where to put it back. So components themselves can have all these relationships. You can make a level to a component relationship, or a level component to a share component. All that makes perfect sense. But today, that's sort of, depending on who you are, it's either baked in or it's just the one that gets most expressed. The spatial containment and all these other set of relationships, those are part and parcel of IFC, but the approach that this looks to take is, well, if you're sharing those relationships inside one of these sort of collections, is it just that the components exist? Do we need to do something special, like actually a scene graph kind of concept? These are the wide open discussions here, because we haven't spent much time, and I don't think anybody's prototyped them. Because if you look at sort of the things that are also happening right now, is like the, say, AI generated scene graph stuff that's happening. I'm just pointing out that it exists and everybody's trying to make scene graphs. So what should we be doing in thinking about this? So the collection at this point is just an array of objects, or array of components. It's really just a question of what else should go in the collection to make it useful. The most clear one to me is, like, if you need to do a global transformation of like a coordinate system shift or something, this is where you want to do it. You don't want to have to do it on thousands of relationship to every object. You certainly could, but it seems like there's some functionality here you want to imbue to the collection. everybody's nodding, but I'm not showing much of detail, so it's hard to disagree.
So if you already have relationships, is it necessary that this is a part of the definition that you set out from the beginning, or can it be added by a user later?
Well, it certainly can be added user later. I think it's probably more of an optimization question if the relationships are enough, but if there's a baked in hierarchy, if I want to make that, elevate that somehow, I suppose is what I'm saying.
So if you do anything specific here, that's power you take away from the user, right?
Well, I think we're saying that the elevated thing is still a user defined concept. Like I want to organize my data by position along the alignment. Then it's a question, is that baked in at a optimized way when you share it? I think is sort of the question.
Okay.
These are the things that we have to discuss that I don't think anybody spent the time on, so including me. So let's not go through that. We'll come back to that. I think now, because now we really have to start getting to okay, if we generally agree on the system. The other thing I didn't even talk about was like, okay, what if I have a bunch of collections and I want to put them together? It's such a ethereal concept. We don't need to go into it. But I think when we start talking about IFC itself, what are the changes we have to discuss when moving forward? So, because basically the discussion now is, okay, we understand this sort of generally this entity component approach. We think it makes sense. Now, what do we do with IFC to put it in it that actually works better, works well, simplifies? I do have my list of the IFC, like there's the whole list of stuff that's very general, but like simplification, location and positionings, explicit units, bools to bools. I mean, that's actually supposed to be IFC bools, developer experience. I think these are all things on the table, and I have a starter list. Shit. Of course. A starter list of stuff we have to talk through. So I think the first one, I think it's next to my slides, is, I think we call them entities now, of just the discussion that came up yesterday is whether those are classes or classifications. This is the sort of BSTD discussion. Like really, in this system, you have classifications and components and they do different things. And they're important distinctions. And I think with just a classification and a component, you can have the flexibility without having to bake it into the definition. So this is my definition. I mean, there's probably better ones, but classification, what the thing is, and the component, what the data that describes the thing. That makes sense. So, classification wall, I could have a component that's ISC geometry solid. The terminology here, I'm just sort of using simplified geometry or simplified class. Like I also have same classification with the pset wall common, right? Two components, the components describe the thing. When it comes to simplification, Devin Sparks went through and did a study of going through BSDD and finding all the, I think you can do this, all the duplicate pset individual properties that associate with different things. And so the approach here is buildingSMART can publish default property sets, I'll show an example of maybe that's not the right way to consume them. But at the end of the day, all I really need is a classification system and multiple classification systems to define my sort of what this thing is. And I think, you guys tell me if I'm wrong, one of the reasons we have such a tight binding is because we have to have rules on, I'm blanking on this, like the linear placement by line of a wall is something that we restrict to a wall. I think maybe there's a couple objects that can use that. I don't even actually know how much we restrict it. Sort of this is not being a developer. I think it's like a free for all, but if we don't restrict it, it begs the question why we even have the definitions besides just a class in the first place. Angel?
Little confused, and maybe this is just the intro slide and you'll get into more detail. Are we looking at a classification? Okay, I have a virtual entity, right? And I want to attach pset wall common component to it. I don't quite grok where the wall classification comes in.
You're confused because this graphic is stupid. Right is components. The left is me just saying, well, those same components still have the same classification.
Okay. So the left is description.
Yeah, it's just a bad slide now that you say this. Okay. Yes. Yeah. Well, I think you'll find that you want to put the classification on every component.
Yeah. Okay. Right. Right. So I had expected that there would be a component that would have classification. So no, now I'm confused again.
Well,
I would expect that there'd be a component that says,
yeah, you can.
Hey, this entity is a wall.
Okay. So what if I don't share the classification component with you, and I just share a piece of geometry?
Then eventually I would have a hard time figuring out how to query for give me the geometry of all the walls.
Right. So it's a question like, well, if this component instance is being used to describe a wall, wouldn't you just not have the classification on the component? Well, it certainly can be, but at the same time, the graphic is confusing. That's why. But if you're using the IFC geometry, the pset wall common, okay. Well, clearly you can read. It must be for walls, right?
Yeah.
But if it's a generic property set, you couldn't ever ask it what it's used for. You could ask what individual thing it's used for, and then you could find the component that's the classification. It's like, oh, I'm used for walls. Or is it just this component is used for a wall, so it's classified as being a wall-based, its function is for a wall.
Well, again, tell me, we'll get to that. If that's, can I attach a pset wall common and a pset beam common to the same entity?
Yeah. Well, I mean, there's no restrictions on the system. We have to define the restrictions.
That's my question. Are there any restrictions?
I mean, not at this point. No. I mean,
do we want to have any restrictions?
Well, so okay, we're talking about remaking what are we changing in the guts of IFC? Are the current pset structures only really there because of how they're defined? Like the domain that wanted to define this thing wanted to put their domain name in front of it, and so that's why it's called that.
Yeah.
Where does fire rating exist? In a
door, wall.
Right, but what components or what psets?
Pset wall common has fire rating, I think.
So why is fire rating in all of them?
Right.
So why isn't what's the use case of these common psets if they're reusing the same things over and over again? So do we strip away that, and then we actually sort of like really restrict things that are actually to a wall in the P sets that are defined quantities and some of these things. And then actually we just make properties that get used as you wish in different components.
So I guess the greater question, again, maybe let's put a pin on this. We're going to go to Oslo next. They have a really lovely opera house.
Yep.
And that opera house has roofs that are ramps, right? So I could very much imagine having a slab that represents one of these roof ramps and having a P-set roof common on it and the P-set ramp common on it.
Yep.
Is this something we plan to support in the future, and how would that appear in an IC file?
I'm the great illustrator, PowerPointer, not the dictator. So
yeah, I think that's something we need to think about in terms of arbitrarily attaching any component to any ID.
So if you start with the
mic's not on.
Okay. So is this on? Yes. So if you start, for example, with a piece of geometry that looks like a wall, but it doesn't know it's an entity that only has geometry, and then you would import that. You would give it a meaning of a wall. You would classify that as a wall later on. I think that's the way this could work. And also, I think, for example, a property set is not like wall. It's a component of a property set. It's a property set. It's a property set component that happens to be attached to a wall, isn't it?
Yeah. So you're getting right. Sorry, I'm trying to find a definition that I made to talk through this, and I sort of forgot about it. So here's an example of me saying to do exactly what I said about this, to make a component out of a singular property, not a P set. So, oh shoot. Because I didn't get out of PowerPoint. So this is on the definition side. So I had we talked about the ID component. I talked about well, I didn't talk about that. Let me talk about this. So this is basically saying, well, what buildingSMART gives me from a fire rating perspective isn't enough for what I need. So what I'm doing is defining a component. This is a definition. This isn't the instance side that actually sort of pulls from. So it's called my fire rating for walls and slabs, because I think fire rating this one should be used on both. So I've thought about some of the things you're asking, but these are not good ideas. They're just a way of pointing out that we need to talk about them on House Correct. So it says, well, actually, this one is fire rating property, buildingSMART's classic definition. But if I look, in the US, we have fire smoke and smoke fire, or what's the other one? Yes, fire smoke rating. buildingSMART has no opinion on this. What I need to fully document my wall in the US is these two other things. And so my component needs to be these three things. And HOK publishes this list of stuff. So the question, like the main thing is, does the P-set definitions as a whole, they obviously translate very well to components. And we could just do that boilerplate very quickly. Devin has done versions of doing exactly this and having the discussions about it. But is it actually how anybody uses data in buildingSMART? Can I attach that to a chair? Fire rating? I mean, well, flame spread is something chairs have on them, but right.
Again, I'm just saying, is there anything that restricts me as a user to say, Okay, so is that
I mean,
is that a
I'm-
real thing?
I'm putting this in here because it's a good idea to talk about it. I'm
Okay.
not saying it's a good idea to do that,
Okay.
or that like if this is the way you should write it ever. But it seems like something I, as the author, as a component, would want to be able to do.
Okay, so the topic of conversation is whether this is truly you can do anything you want at any component, or if there's some mechanism within our schema that says, no, actually, you don't have the right classification to take this component.
And is there a difference between properties and geometry? Because that's geometry makes this messy. Properties is
So I would like to join Angel here on the discussion. Like, do we need restrictions? And if yes, how do they even look like? Is a restriction just another component that I attach to a component stating that, you know, if you're using IFC, then please use IFC wall partition? Would that be, so would a restriction be an additional payload that I send with my other payload?
well. So what I'm showing here is user side restriction, not buildingSMART side restriction.
buildingSMART is just one of the users. So
Right.
it's just,
Well, I mean, I think there is a distinction. Like, should we have a mechanism for restriction, or should buildingSMART restrict?
I would rather first discuss the first question of those two.
Okay.
I think which is how a restriction would look like, and or, you know, how does it apply?
Well, the way, I mean, again, I just pulled this out of my ass this weekend, is I'm going to say, I'm going to restrict this to these classifications. So it's like the 1, 2, 3, fourth item down says classification restrictions, IFC wall partition, wall partition. Notice we don't have partitions. I've sort of made my own namespace up here because we have a separate concept called a partition versus a wall.
But I would expect that to basically point to another component that tells me that this is a classification of some sort.
Yeah, so this is on the instance data, and these are linked conversations. Can any one of the components that's a property, a piece of geometry, have classification on it? Or is it classification is only on one of the components? It certainly makes sense to have a classification component in some scenarios. I just want to, I mean, this is actually what the ID component originally was,
Right.
Just classification.
So it seems to me that, okay, buildingSMART, and for that matter, whatever we come up with here, isn't actually going to control or can't control what components get added to a system, right? So we have no mechanism by which to say smoke rating can't be a component added to a system that's associated with a chair.
I mean, we clearly could. It's whether it's valuable and worth it solves a problem.
Well, what we do have control over is saying when you generate IFC output, that smoke rating doesn't show up because it's not applicable to the chair. Right? If we said, give me all the properties associated to ID X, right? We could say, okay, ID X is a classification as a chair. This, I see smoke rating here, but smoke rating doesn't apply to chairs, so I ignore it.
Well, so I think this comes back to, and this is a, you know, we're blowing it up and ripping it apart. So do the current restrictions serve us any good? And is it like, does the notion of what buildingSMART cares about really, like, why would we make the restriction in the first place? Especially have it as if it has, you know, we're like, and this is why I think it's good to talk about geometry versus properties. Geometry restriction is a good thing to talk about because from a developer perspective, it's a very different problem. Property, it's just another property.
IDS, that's the restriction.
Right. And yeah, you could use IDS and then it's basically take this line out and associate an IDS with all walls. Done. And then again, we've punted from a buildingSMART perspective. Does buildingSMART publish the, you know, preordained IDS files that are the restrictions? Could be.
Yeah, the idea I think is a good one because in my opinion, that's not up to buildingSMART to decide which properties could be attached to which slab or chair or whatever. That's maybe on the user side, and at least it could be at dictionary level, but that's not up to buildingSMART to decide which are the right properties to attach to the right things. If so, we end with a very static thing that may be wrong, and then we're in trouble. If you have something more dynamic, like the user is saying, in my project, this is a restriction, fine. In the data dictionary, this is how it is, and it's, again, dynamic. It can evolve, and then fine. If we do it in buildingSMART level, for me, that's really dangerous.
Although, I mean, that's historically what we've done, right? I mean, P-set wall common is historically supposed to be used for IFC wall.
Right.
Now, we could say in the future, right? I guess I see three levels. One level is, nope, that's it, right? Somewhere, if it doesn't say that, at some level you block it. Another level is, we're not going to block it, but it is useful to know, look, these properties were made with a wall in mind, right?
Well,
acoustic rating doesn't matter for a chair.
Right, but it does matter for your slab ramp, right? And we don't have slab ramps,
right? No.
But somebody could define a classification that is literally slab ramp.
Yeah, that's right.
And what's the restriction for then?
Right. So that's my level 2 here, which is we tell you why we came up with this.
Right. Use a dictionary, what a dictionary is for. This is for the fire rating, and we think it's for this stuff.
Right.
And if it's not for that stuff, then you should be looking for a different fire rating.
Right. And then level 3 is no, just hopefully the description is good enough for you to discover, or you should understand that the acoustic rating of a chair is a meaningless value unless the chair is a piano. I don't know.
Well, so in the room here, I mean, this conversation, the property one, does not seem like a hard development conversation. This is more of a standardization question, right? Does anybody have a developer opinion on this part?
Isn't it difficult to restrict things you don't know exists? For example, in buildingSMART, it's easy now because you know the list of property sets and you know the list of properties, so you can restrict them. But you said this protocol can work well with other standards.
Yeah, absolutely.
So what if other standards see your IFC wall and they go, oh, nice, let me attach my component with my properties. You cannot restrict these because you didn't know these existed.
Well, yeah, this GIS representation of my column is this classification.
Exactly. Yeah.
Or how long have you been, I mean, you're not even waiting anymore for sort of airport specific stuff. Yeah. I mean, you got tired of waiting, so you did something else, but I mean.
I think what I see is very interesting. I think it is also more in the way we as WaterNet are working on more to the link data. So it doesn't matter who's the library or what data dictionary or what co-builder is developing as well. So I'm just looking forward on this one. I hope this one passes through this development. For me, it's a lot of technical stuff, but the main topic lines, the main topics that the IFC schema should improve, be easier to approach. I agree. So.
Well, yeah. Why would buildingSMART not want to make it super easy to make classifications? We have a pool of geometry representations. We have a pool of properties that are domain knowledge. You show up with what you're good at, go through a standardization process, boom, you have more standards. But in the meantime, you can just figure it out, use it as needed to get this standard. What's the disincentive for buildingSMART to enable that?
Well, the disincentive is always the disincentive is always the trade-off between kind of innovation and standardization. Right. Is you want to quickly note that there are now 73 different variants of swimming pools, pools, pool, swimming, place I swim, to say, okay, clearly this now needs to be a standard and the standard will be swimming pool. Please use this. Otherwise, now I have to support or have to understand, I'd like to get all the swimming pools, swimming holes from this project, right?
Well, like there's a Spanish vendor that makes a tool that actually makes swimming pools. This is a BIM stuff. I can't remember the name of it, but I will come back to like how many localizations actually want to deviate from everything buildingSMART has said about what's standard. I think every one of them.
I think that's fine. I mean, I think you just have to understand, right, that as far as you deviate from a standard, then it's up to you to support that non-standard. And anyone who wants to work with you needs to support that non-standard. That's the whole point of a standard, right? I have one implementation as opposed to 10.
Right. Yeah. But I'm yeah. So I think we all in your list of free for all, restrictive, I think do what you need to, but there's still a standard that has to evolve and get updated over time. That seems to make sense. But the you can use it before it's standard in the same way is a pretty valuable aspect too, that should be sort of functionally supported, not necessarily. It's a non-standard implementation, but it's functionally works the same way.
Yeah, if you want a roof ramp, for now, go ahead.
Yep. Okay. I am so out of my depth when it comes to how we're handling units. I didn't realize we're not really handling units right now. We have measures that are just text. So this is something we have to get into. The only thing I have written down is basically the question of explicit units versus what we do today. Wait, where did that go? I don't even have it in here because I have it in an example, but I don't have enough skin in this game to really have an opinion. I made this dumb extrusion version of this just so I could have this thing at the bottom that says length equals millimeters. So clearly there's other places in the world that describe units. I think we use some of them, but especially in this model where you don't have a header that says length unit equals, right? So IFC length doesn't make any sense. So in this context, should we actually just be using explicit units and then, I mean, maybe they're in the data dictionaries, explicit measures right now.
Well, this is my hobby horse. I always want to have like SI units everywhere.
Well, that's fine. Because I think you would, I'm not that American to suggest you can actually put non-SI units in here, but I think you could have just a display value, right? I mean, those sort of things, but.
You could, but I think that's also might be redundant. Like it's it's for human consumption, you can always render it in any unit the user wants to see it. But things are very much simpler if we always exchange everything in SI units, so basically meters. So the only thing that needs an explicit unit is currency.
Time?
No.
Have you looked through the units we have now at IFC? I mean, the measures we have.
Measures?
Well, which are.
I think the only measure that needs unit is currency.
Okay. Well, so then why do we have like 50 different forms of how hours are used now?
Yeah, but we should only have seconds, like whatever is the SI unit for time.
Yeah. Let me explain what I think you're saying. In other words, and by the way, there's still issues with this. We can say, look, all data is stored in SI units, right? And then if you want to show it in feet or smoots or millimeters, right, then it's up to the receiver to show it. There's some question about whether you want to know the unit that the originator was working in, but well, I know Navisworks likes to know that for whatever reason, but let's ignore that for the moment. I think that's secondary. But I think your point was, the only thing that you can't, the only thing that we have that doesn't have an SI unit is money.
Yeah.
Right? Money doesn't have an SI unit. It's whatever, wherever you are. That's why you need to, that's why currency specifically needs to be stored. Everything else can be SI. Yeah. Okay. That's yours. Okay. I agree with that.
Oh, that opinion.
Yeah. I think it's much easier.
So if I understand correctly, so a unit would be also defined as a component and then attached to those components that need the unit?
No,
You
a
would
unit
only have measure. You would say that this property has a measure of length.
Yeah,
It's always in meters.
I mean, so a component is not restricted in the amount of data. You could, I've literally made a component that has all the properties of everything in it. That's a fine component to make. So basically what we're saying is, instead of at the header, you say, oh, length unit millimeters. Well, this is violate exactly what he just said in a second here. Instead of doing that at the header, you have to say, well, in my component that actually has a unit of some sort, you have to call it out there at the component level. Like I'm an extrusion, my vector is in millimeters.
Yeah, that's what I imagine. Yeah, that the extrusion itself would point to the component that defines a millimeter.
I don't think that's a component. I think that's just a property of the component. I have a vector. My vector's unit is millimeters.
That's debatable.
What's that?
That's debatable because I would say that, for example, the unit would be defined in the coordinate system in which the vector is defined in. Because you would also need to tell the vector which coordinate system it lies within, right? Its placement, sort of, or not. Because I could define the vector, so being devil's advocate here, I could define the vector with two angles on a UV curved surface.
All right, so
I'm a mean guy.
This is an interesting discussion about where the boundary is between a thing and the world. And you're describing where the thing and the world are in the same space. So basically my interpretation of what you're saying is when we'd inherited STEP, we basically took a product model that says, this is a thing. And then we made a world out of it that this is just one big thing that's got a lot of things in it. And so what you're describing is these relationships between the geometrical concepts.
It's definitely the question that you posed before is, one of the major questions in any data modeling, like when do you decide that you want a class and when is something just an attribute, right?
Well, let's come back to this because this particular one is important in the sort of location transform discussion because it has bearing on that.
But just to oppose Pasi a bit in having everything in SI units. So I did like though the comment from Angel, which is we are also exchanging design data. And if, for some weird reason I'm designing in feet, I don't want to have the transformation to meters so that the other guy then gets some weird commas. I wanted 12 feet and that's it.
That's only a rendering issue. Like there is enough precision. When you convert to from feet to meters, if you have 12 meters and you convert that to 12 feet and you convert that to meters, and then the receiving end wants to see that in feet again, they will see 12 feet because there is enough precision. So we are not concerned about like sub-millimeter. And even for sub-millimeter precision, it's enough.
Yes, it's usually the sixth or the seventh comma, right?
The counter. So there's an expectation, right? That's simple because either I'm going to show things in feet or I'm going to show things in meters or maybe millimeters or centimeters, right? But even within, forget imperial, even within metric, there can be things like, okay, I want to see my lengths in meters, but I want to see my pipe thicknesses in millimeters, right? So now if I just said, oh, everything in the file is in meters, that's the SI unit, right? Now I have to go through and find the 57 attributes that I actually want to display in millimeters because they're pipes.
Yeah, the burden is on the, let's say,
So
receiver, right?
that's annoying as a receiver, right? Because now I'm seeing my pipe thickness as 0.05 meters. I don't want to. I want to see 50 millimeters. That's what I expect to see.
But this has nothing to do with the source data, right? This has everything to do with what you're looking at in the software, like the UI. Do you care about the source data having this information in it?
I care about knowing enough that it's not a burden on the user to see the pipe radius in millimeters.
Yeah, but so there's two options. The burden is on the user to configure his environment in the way he likes, or the burden is on the implementer of every software that supports this standard to screw around with conversions of units. So what's the bigger evil there? I think the bigger evil is to mess with the implementers versus messing with the user, because the user is going to have personal preferences anyway. You might want to see it in millimeters for the same project for one user, and different user want to see something else, right? It's a personal preference for the user to decide how he wants to see stuff.
But we're talking about geometry. This is simple. Other people care a lot more about how things are measured, though, when it comes to testing criteria. How is this handled in like the product world? Like, is it all SI units except for money, and then there's a display measure? Like, how are they handling this? Because I mean, this is where all this stuff, like,
okay, so taking the one product I know, right? Revit. In Revit, you have everything internally is stored in some weird combination of imperial and metric that's irrelevant here. But the user does have a list of, here's a bunch of measures, and here are the display units I want for that. But there isn't one length, right? There's pipe length and pipe thickness, right, and dimension. So there's many different types of length, and I might want to see all of them in different ways.
Right. So the implication of what I'm showing on the screen is actually, I'm defining a component, and I actually care that it's in millimeters. And then it's just a question of, this is display or storage, right? Because that's the variable here, right?
Right. To be clear, like, I don't care. Like, I agree. Everything can be stored in SI units. I don't think that's an interesting question. The question is, how is it presented?
Right.
So do we need, it could be solved by saying, okay, we will have more than one type of length measure, because we know we have an industry that has different types of lengths. I'm just throwing it out there.
Well, even in the fire rating example, I can't remember what the fire rating is actually. Just, it's probably a number.
It's like minutes, I think.
Right, but that's how not the U.S. code isn't minutes; it's hours. Right?
All right. Okay.
So I mean, the point I was making of bringing it up in this context is I need to measure it in hours. Because that's how my code looks at the world. So
yeah.
So is it again back to component defines how it's presented?
Well, this fire rating is, I think you have like 1 hour, 2 hour, 3 hour. These are basically like labels.
Right.
If you would say that this is a time measure, then you would store that in seconds, and then maybe the UI would display it as like 2 hours and so on.
Yeah, I mean, right. Greg has not spent the time implementing what I put on the screen software.
Yeah.
This is a discussion topic. So, but yeah, I mean, but this is a valid, let's just do what you just said. I need to actually think of it in hours. So I want a real unit, but I actually have a display mechanism, which is a concatenation of display unit plus hour.
Yeah, well, this fire rating is kind of odd. Everybody think that as a time unit, but it's, I think in Europe, I think in Finland, it's like 60 or 30 or something like
Right.
minutes.
Yes. Other companies are minutes.
Yeah. So but it's basically, it's kind of label. It's
So
not, you don't have like 34-minute fire rating or something.
So we're saying in both examples, this is just how I want it labeled.
It's more a category, right, Pasi? It's
yeah,
more
it's more, you
sort
don't
of classes.
Yeah, it's kind of enumeration. It's you don't have like 37-minute fire rating.
Because nobody really cares about 37 or 38. Yeah, they meant the
Right, but so that would actually go towards a strongly typed fire rating, right? Because you might have a finished fire rating, right, which is in minutes. You might have an American fire rating, which is in hours. You might have a universal fire rating, which is just a label.
There are 45-minute doors in the US.
Sure.
For example, yes.
No, well, I mean, okay, well, those are 2 digits away. Besides that, what's the difference between those 2 digits?
What I'm saying, if we want to, I mean, fire rating, if I would be consistent in my thoughts, I would say that this is a time unit, and then it is up to the software to display. If you are using a software in US, you would display it in hours, but it would be stored as, say, 3,600 seconds if it's 1 hour.
Okay, so the follow-up for this.
Just to comment from the manufacturing end there, guys. To put a product, a wall on the market, there is in all over the world, there are standards defined to test, and they will always deliver the unit and measure the values. Everything is there. So that's predefined in the already existing methods, which you test. You go to laboratories and test, and you get the number EI30 in typically in Europe, different in the US. So this framework already exists, and I think this connection is the connection to the manufacturing world. So it's important to understand this correlation between test methods defined in the US, in Europe, and how it's implemented here.
Yeah, and I think that the minimum we should try to agree on is, well, if we're going to get closer, we should have a discussion about, do we get rid of the named measures, and at the component level, we have the measures, and are they, so basically in IFC, let's make that restriction here. We have, we name everything, even things that IFC length, right? That serves no benefit in this approach. And so no matter what we're doing, are we comfortable with suggestion that we're just saying, we're actually just going to call it the unit, not a name for the unit? That's because in the context of what I'm using this measure for, the length of this wall, I'm going to be in that context.
And as an example with the pipe is that the test methods defines like the length of the pipe, and it's measured in meters in Europe, but the dimension is measured in millimeters. And these relations is already there. They're
sure,
there,
but
existing.
I mean, if that is stored in IFC, they can still all be stored as meters. It's just the way they are displayed.
Yeah.
So we shouldn't like, the other thing is that if we store the units in the IFC file, so you would have, for example, the length of the pipe in meters, and then the diameter of the pipe in millimeters. Would the receiver of the file that is looking at, would they accept that the IFC file is dictating the units that they are seeing? Like, I don't think so. They would want to, if they want to see everything in meters, that's their decision.
Well, so I would say, like, yeah, like there's a clear distinction here. If somebody authors a component, they should be able to dictate it, because like I'm the authority on how to measure this thing. I made a component, how you measure it. But you're pointing out like what
the storage and the display
right.
are two different things.
Right.
Storage
so
can be always in SI unit. Display is up to the user to decide.
Okay, so we
agreed with the first part, right? We can
Storage
agree
and
that
SI.
storage is at SI units, that no issue there. I still think that there should be here is the intention for how it should be displayed. In other words, pipe diameter is intended to be displayed in millimeters. It was created by someone thinking in millimeters. And by default, you can change it in your system if you want. By default, you want to see 50 millimeters.
But if you get pipes from two different authors, from two different systems, and they use different, different diameters and preferences.
Yes.
So you would see the diameters of pipe coming from one system in meters and coming from another in millimeters.
Right. Or and another in inches.
Yeah.
That's right.
So
yeah, but that.
What was this is a perfect example. The dumbest name in the world we have for how Canada works is soft metric. I don't know if you've ever heard this term. So they work in the metric system, but they use imperial unit products. So they have the grossest numbers for everything ever, right? Like nothing's 25. I think drywall is 23, right? So in that soft metric world, they are actually, they're displaying the millimeters. I think we're not having the conversation about the storage, but if I have the Canadian version and the US version of that same thing, Angel is advocating that one can decide I want to display the same information differently. I'm not certain why we'd restrict that.
Right. Again, to be clear, I'm absolutely not advocating against a user being able to change it. I'm saying what should be the initial view of the data. Another perfect, because again, meters and inches and feet is not a big deal because I think most people can
radians and angles and stuff.
BTUs, right? Weird American units that people are going to know British thermal units. They're not going to know whatever the metric equivalent is, or force, weight or whatever. So
kips.
Yeah, right. So you're going to get an interesting number. You're going to get 50 millimeters. If you see it in millimeters, you're going to get 11/128 inches, right, or whatever, if you translate it. So there is value to seeing the clean original number. And that's what, and inside the file is stored as SI. But
so then if we're going to have this discussion, we should add on what's the precision. I'm not going to touch this one, but this is the messiest one. Well, it's the easiest one to make decisions on cleaning up IFC. Like in the component, like what we should do is a harder part of the discussion. But I think I don't think we're saying any novel. It's really just a question, in a cleanup of IFC, can we get rid of, do we start to think about on the IFC length doesn't mean anything in this context, right? Like that sort of stuff. And then there's a question about the sort of, is it IFC bool or is it just bool? That's a separate topic, but these are the same family of, we've just relabeled stuff that's the same thing. So like we have IFC text and IFC string, this is sort of stuff. Anybody actually have an opinion on this, or we can table this one because this is the least interesting of all the ones we should make progress on.
Can I go one step back? Because at some point there was a question around, what is an entity and what is a relationship and what is.
Yep.
So, but I think, am I right in thinking that in one of those data, you call them payloads, I guess, you can have very many information.
I mean, you literally could put a full IFC file in one component and call it an entity.
Okay.
Done.
Right. So the entity level is how whatever I think makes sense as a distributable set of data.
Yeah, so like Greg V from Autodesk, when he gave a presentation, they're online, we can share the links, but he said it's like, you should think about a component as the smallest logical unit of data that makes sense to share, but not smaller.
Yeah, okay.
But there's no restriction on the upper limit, but it doesn't make sense to use this system if you're going to put a full data set in it.
Okay. So I have perhaps a more abstract question here, which is, as you've just said, like you could put the whole IFC file or model within one component. I fail to recognize how this whole discussion that we're having currently, which I really like, the component and being more abstract, how this connects in any way whatsoever to IFC 5 or IFC for that sake.
Well, no, so the second you make a component that's just like a discrete piece of information, it makes a lot of sense that, I can't give generalized information about units or display or how I'm measured. I actually have to give specific information. So that's how we got to, I'm in SI units, but my preference is this length is in meters, diameter is in millimeters. And we have a generic version of that in the header today, because we have a bunch of measures that I think can be in different units or display units. Yeah. So we're migrating those to say, you specify directly on your components that this named dimension is in meters, this thing is in millimeters. It's just a translation of actually what we're doing today.
I mean, you can do that with properties already, that you specify their own unit on the property itself, because you just override the default that is defined in project, but that's just IFC mechanics.
Right, but
that the components right now discussing are not necessarily overwriting or.
Well, there's nothing to override. There's no header of the whole like the whole component.
No, I can define a component that says default units.
Well, so the main discussion is, it's really display. Does a component, like, I think we're getting on the weeds, because really we're having a discussion about, does the component get to tell you how it wants to be displayed?
That's not necessarily the topic I want to address right now. Okay. But I agree, this is also something we can discuss, but I'm more of considering also in one of the slides, you also had that, a component could be a BCF topic, or a component could be a GeoJSON geometry, or a component could be whatever, right? I'm still failing to recognize how this is IFC 5 and not being something newer around it. Well, that this should be perhaps branded something else.
This is an interesting reflection, because basically you're saying, we should cover everything. And what I'm saying is, well, the system can cover everything, but we're restricted to IFC. And we need to optimize IFC for this thing. So we're within those bounds. I absolutely agree, but it strikes me that solving all units is not something we're going to solve. The thing that we need to talk about next, though, is a thing that needs to be solved across domains, because if we need to position two data sets next to each other, we do need to take that out of IFC and make a separate discussion. So it's really, we agree on the framework. We like how it breaks data into pieces. Now we have to put IFC in it. We will boil the ocean if we say we're making a framework for all measures. We're not. We're saying how IFC works in the system. We have to make those rules next. That's why we have this restriction. And IFC 5 is basically putting IFC in this thing.
Can I just try to rephrase what you just said to see if I got it right? So you're saying, if we have this complex framework of components and orchestration, and we'll see how complex it's going to be in the end, so what are the consequences in the IFC schema to make these individual components as rich or as small as possible, so that they can nevertheless easily integrate with all the other. So what are the consequences in terms of the data structure? I think we have this kind of, we need to find the right balance between, like to say it in Eric S. Raymond's analogy, between the cathedral and the bazaar here, right? So in the past, we've been doing cathedral style design of IFC, so defining every property and everything like fine-grained. Now we see that the world is much more complicated than that, and we have this even more complex negotiation and exchange and obsolescence mechanisms. So what are the consequences to what is the best form of IFC to sit in that scenario?
Right.
Is that
yeah, because that's the really, so yeah, to replay it, we started with IFC. Oh, the requirements are IFC, it has to be multi-format. Well, that's not IFC, that's this framework we put stuff in. Yeah. So we come back to like, oh, we need this protocol framework, and now we're at the point where we have to put IFC in it. Yeah, very well described, better than I can. So. Okay. So this is the messiest one, especially we want to talk to the other domains, is sort of, and this is me sort of thinking about how we got to where we are. So we took a product model, and this is where we started to go here, and said, well, we'll just use the way they sort of place stuff in the world for everything, you know, axes, 2D, 3D. If somebody knows how to list out these things, let me know. Then we have new alignments and so forth. But they're all mixed together, and some are used for certain things. And they're literally, like, my interpretation of this is they were really good at making a single piece of geometry inside of a part. And that's what, you know, step comes from. But when we expanded this multi-part stuff, we've sort of gotten really messy of how things are placed. And so it's a question of, okay, if we need to be able to place a chair in a world, do we have to have the conversation of, well, internally to that chair, let's say we're still using step today. We're using sort of basically the constraints of that geometric measurement method to put it in the world, but then we need to put it in a different world because we can't use the IFC placement logic to put it next to geospatial data or point cloud data, because we don't have a generic system. We don't have like transform XYZ rotation. We don't have these simple concepts that can relate to these other data sets. So if I have bag and cup, these two measure themselves, they don't talk to each other. We need to come up with a way of saying, oh, I can relate this to that without having to have internal data structure relationships. So like location is one of these things that we have to back up and talk to the GIS community and come with one way of doing the simple stuff. It's the hardest one. It's certainly doable in the system, but it's more of this is like what's inside this little box is IFC today. What's outside is not. Because we have to do, you know, everybody knows we have these sort of problems, but we also have this problem.
I don't think we have this problem. I don't get it where you get it from that we have this problem. But I might misunderstand what the problem statement is.
One possibility is that I mean, we have these like different worlds that kind of coexist.
Right.
So the way of that this could be solved in the IFC world is that we have this the coordinate system, for example, that would be a component.
Okay.
And it would be attached to, say, a building story, or a site would have and they could refer to each other somehow. Like,
yep.
They have the hierarchy. So basically, we could still use that. And then if say you have the GIS thing, and it has its own way of referring. And if you want to refer to, or take some GIS stuff in your software, then you need to understand how the GIS coordinate system works. So that would be one possibility. I don't know if there is, of course, if we come up with one way of describing this location, but that might be difficult because, of course, if they are really similar between these three worlds or multiple worlds, then
right. So we do not have. This is not to solve the Ublake spheroid problem or any of that stuff. This is my shapefile or my GeoJSON is in one projection, and I have a building next to it, and they want to be aware of each other's location. And right now our solution is to convert. How do we not convert? Like, do we use a relationship to do that? What are we doing? Because basically we have an IFC GIS working group. The federal highway system has GIS data about the same column in the two systems. I want to know where there are, but I have two different ways of measuring them today. We don't necessarily have to come up with the same underlying sheet of paper that we move around, but we do need to have a way to say, okay, I can relate these two together and can position them in this world versus that world together when I put them together, without conversion. And this is the meaningful distinction. So instead of converting data from one to, put an IFC and it'll get the right spot.
No, I wouldn't.
You can't do it without conversion. That's like putting together a document in English and in French and not translating English to French or French to English in order to read it.
We have no way of specifying transformations between these two data sets without literally making one into the other.
But if you want to, for example, if in Solibri we would want to display some GIS stuff, we would need to understand the GIS format anyway.
Right. Yeah, so, it's an internal representation, right?
Yeah.
And then where it is.
Yeah. So, but so if there is in GIS there is some thing that represents, for example, building.
Well, let's do something that's simpler.
Okay.
Point clouds.
Yeah, well, point clouds. So
is that simpler?
Well, point clouds. Okay, let's say they have non.
So just to understand your requirement, Greg.
Yep.
So your requirement is you have two data sets. Just this theoretical. You have two data sets, both in a different coordinates reference system. So with a different projection or a different definition of what.
Well, let's not even use the projection stuff. Let's say they're a different but both Cartesian systems.
But why couldn't you? Because
Cartesian system is not enough yet. You haven't defined its position on Earth. Cartesian system is anywhere.
What I'm saying is the requirement is I need to be able to position these two data sources together without converting one to the other. Right. I need something externally to bridge this gap. That can be a relationship, that can be an external coordinate system, that can be many things, but it has to be outside of IFC and outside of the other data set.
But each data set needs to know in which coordinate system it lies. Otherwise, each geometry is in the clouds.
Individually, they absolutely do. But yes. if the required, which, okay, so. Yeah.
You have to, even if you use, as I said, as a third coordinate system, but you have to do the conversions. But anyway, the only one thing that is unique in terms of positioning is latitude, longitude, elevation. So this one chair here has only one position in that system, but it has 1,000 different positions in 1,000 projected coordinate systems.
Okay, so then the question is there I mean, this is where we should lean, because this is not we're not going to solve this on the IFC side. What is the generic mapping logic? Because like, you know, I play around enough with the software, like TIFF files come with their offsets, like these sort of things. What's the right way for the GIS community to tell how us to position in the world? Sort of the question. And mechanics.
That's already a solved problem, though.
If it's a solved problem, then why is it so hard? It's solvable, but we have not solved it because we can't not convert. I mean, you can do it the other way. I absolutely agree. I can give somebody an IFC file and the GIS world can place it. The BIM world can't place GIS data.
Yeah, but that's not a problem of IFC.
No, it's a problem of two representations not being able to map to each other. That's the problem we're looking to solve.
Sources work and make sure that they insert. I mean, any infrastructure design package would understand how GIS reference locates information, right? So it would digest that information, and it would, of course, work into a projected coordinate system that is appropriate for the project. But it would understand, again, the GIS side of things, and it would, of course, work in I mean, the design tool would measure and understand the coordinate system it is working in. So if it gets an external data like a building that is not located, then it will position it as per the way it is described. Right. If it is described.
Right. I think the distinction here, if I'm starting to understand it.
Sorry.
There's data, and then there's business logic. Right.
You need to describe this because I always forget the way to make this distinction, but yes.
Right. So business logic is, how do I take the data and use it to create something? Right. So a coordinate system tells you, I'm going to take your point, you put a transform on it that's described by this data, and that tells you where to place something. Right. And in the architectural world, our coordinate system logic is very trivial, right? We have XYZ, everything's linear. Then GIS stuff can be. Yeah. Sorry? Right. The earth is flat. Exactly. Right. For architects, the earth is flat, and for GIS, the earth is ellipsoid or whatever the, not even round, right?
It's an oblate spheroid.
That's it. Thank you. Right. So it's a more complicated logic, right? Because now I need to know a point, and based on that point, there's a very complicated. So I going back to the English French, I do agree that you can put the data in there, but in the end, you're going to have to know how to apply business.
Let me ask this more succinctly. Is there a data standard that we should just point to in the geospatial world that is a generic way of doing this transformation? And what's that standard?
ISO 19111.
Okay, and it has a geodjacent or adjacent representation, or how is it expressed? Well-known text. Okay, so the simple answer to this is we should adopt a well-known text component that can do exactly this.
That's already an IFC for the tree.
That's why I say it's a solved problem. So I don't really get yet what the problem is, but I believe I understand your problem, which is you as a user are not having the capability of doing it.
So you as a user are missing the functionality in software.
I don't get the briefings on what's in that well-known text is added. Like, how are we encoding this? Is it a blob?
Yes, it's not the best solution yet.
Okay, okay. Well, then you're mostly right. It's a solved problem. We need to embrace well-known text component definitions as how we do these offsets. Yeah. Okay, never mind. Thank you.
Glad to have that discussion. Yeah.
Easier problem.
So something to consider, right? Then is part of our solution. Okay, vendors use ISO that one, or vendors,
That
we're
one.
going to work with toolkit providers or buildingSMART provides a toolkit or whatever that says, hey, here's a little engine that if you do put the data in the right way, will help you get that data. So, and I'm not saying which one, but those are two possible different solutions here.
Right. No, but I think, well, that strikes me that the implementation of, I'm assuming 4.3 on the infrastructure side requires the use of the well-known texts for placement, or will.
For the definition of the coordinate reference system, the placement itself in IFC remains as it is, because it's versatile enough. But the definition of what the coordinate reference system of the whole file is, that can be done with the well-known text.
Okay. Okay.
And there's a workaround for IFC4 and for 2x3 as well to have that.
So it's then becomes more of a question: do we use the same logic for things that are not geospatial? Do we adopt well-known text for point clouds and basically just anything that's got an offset from the base IFC system? And even if it's not,
coming back to my question from before, I don't see this as necessarily an IFC problem, but more of, can we have a component that's a point cloud? I don't need point clouds in IFC.
No, you don't. But I need to be able to put them together. This is the IFC meets this world that I need to solve this particular problem, which is put IFC next to data that I don't know. You're 100% right. So I don't need to put point clouds in IFC. I do need to be able to relate them together and make that positioning translatable.
Exactly. So the point cloud knows about its position. The IFC knows about its position.
And if we have well-known texts, like basically we're saying strikes me that this is an easy thing to adopt.
Exactly.
So the next
That's how it was designed.
Transformation might not be easy.
What?
Yeah. Transformation is not easy, but at least you have the data.
You should give your presentation from Tokyo. It's still one of the best presentations. This is where I learned oblate spheroid.
So we all love oblate spheroids, but most of the problems I'm encountering with IFC at the moment are like long time Boolean extrusions and stuff like that, and complex geometries that are not necessarily needed for
sorry,
I think you're probably pointing to a solution already, but
well, no, I'm getting to the discussion.
This idea that if you want to make invite more implementers to share and love IFC, then maybe we want to have like a simple ways for them, like to embed geometry, an easily interpreted geometry with everything that we move around.
But it's almost like we had a conversation about GLTF yesterday.
Maybe.
And but yeah, so this is to jump to this discussion. So I have no idea what to do on the semantic advanced BREP side of things. I do know almost everybody is in agreement that because of the system, we can adopt other representations of, especially mesh representations, and this doesn't solve coordinates stuff. This is just, why do we have a separate mesh representation that you can't display things very well with, can't show it on the web very easy. So the basically first implementation of this IFC5 system would say, well, I'm just going to use GLTF as my display of mesh. So that's the simplified left side of this screen. What to do on the other side of it, I've started to have the conversations. Like, I think I get the impression that we're happy with the semantic approach for the alignment and some of the newer things that have got into the technology. I think the middle ground is the place where we have the most work. Angel, what's the worst geometry? The advanced BREP, which is the faceted one, which is.
Oh, yeah, I was saying that, faceted BREP is kind of the worst of all worlds.
Oh, yeah, the faceted BREP is the worst of all worlds.
It's not as good as advanced and doesn't have the compactness of polygonal face sets and such.
Right. So in this component world where we have this little capsule we can put this stuff in, we can put anything in the capsule. Clearly on the mesh side, people, well, let's just use DLTF. You can make a display, it solves a lot of the presentation stuff. This is going to be the hardest one on the sort of advanced side of things. I mean, is there anything we don't like about, this is not decision making. This is just, I don't understand where we are all the time in this. So on the infra side of things, is semantic working well? As in well, I'm going to be pulling it out of my ass if I try to explain it. Can somebody give me a better example? I mean, there's an equation for these curves. I know, but can somebody else help me with this one? Because it's not geometry. It's the definition of the curve.
Representation.
Right.
Yeah.
Yeah, the semantic representation. How do you technically describe this?
Well, okay, so IFC has parametric representations, of course. What? Extrusions, by swept solids. Basically, it has swept solids, which includes extrusions, subdisks, other such. It has B-reps, meshes, and then it has alignments, which are purely parametric representations of complicated curves. That's right. So I think your question is just, is something missing?
Well, what I heard last night from Dimitri is that actually the definition of the curve, not a piece of geometry, is working really well.
Well, it was defined by business experts, so it speaks to them for sure. But again, this brings with them with it a lot of legacy. So the way that alignment curves are described on the business logic. Okay, let's split this into business logic and geometry definition. Let's avoid semantic because there's semantic in geometry. So business
okay, that's
logic,
why I was confused. Okay.
Yeah, business logic and geometry definition in IFC. Okay, so alignment has a business logic definition using the terminology that are convenient for the business expert, because that definition came out of a project where business experts describes how they were used to define alignment on paper. Like there is a sequence of segments. Each segment is either a line, a transition curve, an arc, and so on and so forth. Each segment has some properties, speed, and whatever. And then that is described in IC as a business logic. And then there are the core geometrical primitives, which are the lines, the clothoids, the arcs, and so on, the points that are used to reflect or give a shape representation, to use the IFC language, give a shape representation to the business part. So the business part can exist in IFC without its shape representation. And most vendors already told us that they are going to exchange just the business logic part, and they will rely on their own geometrical kernel to recreate the geometry. Because exchanging geometry is also possible, but might create inconsistencies. I'm making 5 years discussion very short.
This is how I work all the time.
But that's in a nutshell the summary of the distinction between alignment business logic and alignment geometry. But your question is, do we work IFC to work in this way all the time, or are we fine to have this distinction only on specific subjects? If I got on your question.
Yeah, this is basically where I'm going, is like, can we carve out where business logic is the way to work and not business logic is the way to work? And if it's not business logic, what do we have to get better at? Like, do we have to?
So my stand on this has always been, we should always have at least the highest business logic representation we can reasonably support, right? So for alignments, we've done all this work in 5 years. We should support that representation. Then, in addition, we should support whatever reasonable, dumbed down representations make sense for a particular type of thing. So, as an example, I could imagine that you would have the, Boolean operation recipe for an object and the mesh equivalent, right? And that would satisfy a viewer that would want the mesh and a CAD system that would really want to construct it itself. You could even potentially have that and the BREP, I don't want to do Booleans, but I also don't want a bunch of facets. There's no requirement for any of this, but the more you provide, the more option there is for someone to say, oh, this is the form I want, give me all your beams as meshes because I'm just displaying them, or give me all your beams in the recipe form because I want to do some advanced calculations.
Right, because what this translates to is like, oh, I can specify I need 4 components for the alignment: horizontal, vertical business logic, horizontal, vertical, discrete curve. I'm at geometry, but and then so it's just a question of, is that the right way to approach this? So we, on the what every vendor has to support from a geometric perspective, we have really clear distinctions between A, B, and C, mesh, BREP. So the curve stuff is a little bit like GLTF is perfect for objects, solids, whatever.
Yeah.
Right. But curves is a harder problem.
One of the things that 4.3 added that I really like is the fallback geometry, right? So here's some fancy infra stuff. Oh, okay, architect, I'm patting you on the head. Here's a nice mesh for you. But that gives you the option to say, no, I want to learn how to support blah, or no, it has no value to me. So go ahead and give me the simple stuff. So I think that should go into IFC5, that we have multiple ways of potentially representing something. And then yes, later on, when we think about recommendations, requirements, however we're going to go forth, we can say, look, for these cases, you really need to have both as good as you can in a mesh. And for the other cases, say alignment, no, I'm sorry, like actually no one wants a polygonal alignment.
Right.
Like just give me the business logic.
Is business logic, so based on what I just heard, business logic has actually no bearing on what geometric representation we use. Well, it allows you to reconstruct it, but the business logic is not step.
The business logic is the text underneath the description that says, this is what this data means, and this is how you use it, right? Everything has business logic.
Right.
Right. If you have a parameter with a name and a value, the business logic is display the name, tab, value. Right.
Because I'm basically trying to ask, like, you could describe the business logic in any text anywhere without issue for this alignment. It has nothing to do with the fact that we have step. Is that correct?
At the beginning of the project 5 years ago, the requirements from stakeholders came in the form of a CSV. So a bunch of like starting length, starting point, arcs, curvature. So a bunch of, and then we translated those into entities, IFC entities and parameters on the business logic side. And now you are able to describe them in IFC, but in the asset management system of each of the stakeholders, they are described in Excel, CSV, whatever.
Right. The business logic says, given 17 variables, apply this formula to them.
Right.
As long as I can get the 17 variables, it doesn't matter if it's step or CSV or.
So we can, I'm trying to get to a point here. You're getting frustrated with this point, but what we can slice off is, can we put business logic in JSON representation, and it has no bearing whatsoever on this problem because it's easier to exchange. But, the advanced BREP, we have to stick with step long-term, or do we look somewhere else?
So if you serialize in JSON or step or XML or turtle or whatever, that
doesn't matter.
That's a completely different discussion than to what kind of geometries do you want to have.
Right, but this is
I can give you a BREP in GLTF. I can give you probably not a BREP, but like
only triangles.
Only triangles. So I can give you triangles in GLTF. I can give you triangles in IFC, and I can serialize those triangles in the IFC data model with STEP, with XML, with JSON.
This whole question is like, what are we doing long term? Is STEP the for every geometry we have to make explicitly, is STEP the answer? And for meshes, most people think we probably keep it around, but there's a better version.
I think what you want to ask is is IFC the answer to do geometries?
No, because IFC is geometry plus other things.
No, what I'm saying is, do we use, in IFC5, do we use IFC polygonal face set with blah, blah, whatever it's called? And we can change it to JSON, right? But do we use that? Do we use the description?
Yeah, okay, yeah. So yes, sorry, I'm making the distinction here. You are correct. Yes. Are we describing it using the IFC version of how to describe it? The geometry, not the business logic.
Exactly. That's the question, right?
Yeah. Right. And is there a better solution? Is the better solution just going to what a modern version of STEP? Is it?
For example, yeah, because for what I really like about IFC and STEP is exactly this, what Angel has spoken previously, right? You have this how to build up the geometry type of recipe, right? That's not available in GeoJSON. It's not available in any GIS thing because they don't build up the geometry.
Right.
They just describe it, right? So they only have the explicit geometries, but the implicit ones are really the power of IFCs, that you can have a swept disk area solid something for the rebar.
Well, the part of the problem here is like finding these definitions are nearly impossible. Right?
Which definitions?
Well, like how do I describe? Like I try to make a comparison. I went to an open source geometry library and looked at a method for making a curve. Provide these two parameters, done. Finding this in the buildingSMART world, Jesus.
Well,
is this somewhere?
You need the 17. That's the thing, right? Because you are building up the curve. You usually need many more parameters. But those that are dealing with geometry kernels, they know that they need these parameters.
Right. So one of the simplification questions is implementation details. It's really robust, but is it the only thing we should do?
Well, so okay. I mean, when we're talking about IFC5, not 5.1 or 6 or 13, right? We should probably favor as much as possible everything we already have, right? Because again, we don't need to change everything all at once.
Correct.
Right. So if we like swept disk solids, and I don't see why we wouldn't, they work pretty well, right?
Exactly. Yes.
Then we should take that and modify, because now it has a JSON description or whatever.
Yeah,
right?
if that's the right thing to do.
If that's the right thing to do. But there will be a component, or there'll be a components can use swept disk solids. And yes, and somewhere there should be a very nice description of what the data means for swept disk solid. Okay, you have a directrix and you have a radius, and here is how you would take that information and generate it, which does exist in the documentation. It's just hard to find sometimes and maybe hard to understand. And that could be
that could be my limitation. So
and there are some things which we might decide we don't want anymore, and there's some things we might want to tweak. But I think we shouldn't make all the big steps all at the same time, right?
Well, so I think it's perfectly fine to say our actual two moves are GLTF, and that actually doesn't change anything. That's in addition to. Good to have that discussion, and then there's a cleanup of. Well, are we going to make? I guess are we going to make advanced BREP work or not? And then what do we get rid of?
Advanced BREP works. Or
I think it needs P curves. But other than that, I agree.
P curves are cool. Yes, of course. But I think I think the third question that you need to add to that list, Greg, is what Angel has said before. Like, in some cases, I want to have both the mesh and the recipe.
Oh yeah,
and we need to perhaps invest more in defining this, let's say, restrictions /requirements / whatever you want to call them. But what's the combination for a certain scenario that you want to be doing. So for example, you could say, yes, let's do GLTF if we are doing web visualization, but I want to do a design transfer. I don't do web visualization. I need the recipe.
Well, so I think I think the closer we get to, I have a way to represent geometry, and we don't make a kernel, but something that looks like a method. That's like this is how you order the points. All the everything has to be explicit because they're components where we can make them very explicit, right? Like this is the only way you do these things. I think that's all we're saying. That what I'm confused by is if geometry works so well, why does it never work?
Certification. What?
So then these are unit tests. Like what you're describing is a unit test that you support this representation, and that's a component. And if somebody asks for the component, you have a unit test that proves you can make it, and you have 1,000 more that are variations on it. So, okay.
Yeah. It's a separate conversation. 30 seconds, I'm done. It's a separate conversation of why is it difficult to exchange 3D data, right? And there's no representation that's going to make that simpler.
No.
Right. So we can come up with techniques for that, but that's a separate discussion.
Okay. So just to there's a.
From my perspective, we are trying to, instead of talking about writing guidelines, how to use geometry, we are trying to just cut it off. And I mean that, for example, I mentioned yesterday, the step world successfully living with the same geometry representation because they main limitation for everything. And if someone go to step world to this guy and say, okay, let's simplify your geometry, they just ask why. Because they already simplified the geometry, why are a set of guidelines. And here I'm maybe also on that step.
This strikes me that just as we have a bunch of representations, but we haven't provided strict rules to use them, and then we have some improvements. So it doesn't seem anybody actually feels anything like we need to do house cleaning. It's just.
Well, no, I do. And the reason I do is because if we are thinking of an environment in which we have like a complex negotiation of very many parties that can do their own components, and so we are thinking of engaging with more players out there. We are trying to make the IFC ecosystem or the construction ecosystem more welcoming to other people. The semantic representation that we have right now is a difficult step for them to engage with.
The business logic version.
So the business logic. So if I need to get a rebar, and to do that rebar, I need to understand how to build. I need to understand the 22 ways in which I build a profile along which my rebar is extruded. I'm making difficult for more people to come in and join us in this complex sharing ecosystem. If along that semantic business logic, we tell people, oh, in IFC file, you always put up a GLTF. Plus, feel free to export your rebar as a semantic business logic. We have made it easier for a huge community of people out there to come and play with us. That's my hope. And then, so we lower the entry, the bar to more people joining in the construction community.
Looking at the restrict time.
Yeah. But we are discussing, as I understand, at this point, you in your concept, we are removing that solid and BREP level. But in our discussion,
Yeah, we suggest to keep it as it was before. So for newcomers, it will be possible to keep rebar business logic and also to provide the GLTF representation. But for companies who lived before with mathematically correct BREP representation of rebar, we would like to keep ability to live with that representation.
Of course.
Oh yeah, on this, yeah.
No, that.
Oh, okay,
Let me be clear.
Yeah.
I never said, "Oh, strip BREP."
Yeah,
no. I said, but you want exporting IFC, add to the data set something that people can use to display on the web, on something that is easy to do, and that does not rely on very complex kernels that different people get different as well. Yeah,
it's fine.
Okay. So we're going to wrap up. There's a storage discussion to have. We're not going to have that today. And we can talk about the APIs. So the wrap up, I think the framework of using an entity component system, everybody seems to agree. Everybody sees a clear path of actually how IFC as it sits today could fit into it. There are some details we have to work on like this last one seems like the simplest one. We actually just need better documentation on how that instructively to use our geometry, and we need a simple representation that's easy to use, and our triangulated world isn't the right world. So let's put what we have next to GLTF as a starting point, and then we go from there. I think the next steps forward strikes me is we need to start to prototype this in more detail with IFC data. People have, we've done pieces of it, but we need to put it together. And so I don't think we're ready to start making IFC 5 yet, but I think we have agreement that this is what the direction it's going to go. Yeah, is that fair? Right. Regular meetings, starting to prototype things, working through the details. Absolutely, that has to start after this meeting, and we'll work with Leon and others to help coordinate that. I think it's just a realization that we have the framework, not the details. Okay. Thank you.
I don't have too much comment. So one comment is that we're trying to cut lunch a little bit short because we have a presentation from Stefan after lunch, but he needs to leave as well. So the sooner we can get back, the more we can see of his presentation. Have you seen the audience? Yeah. So after lunch, we have 1 hour to do again this to continue the challenge. We have IDS files we have created yesterday. We should just imagine that over the night, people also created an IFC file. I know that was short notice. And then we are now at the step where we have some vendors that are going to present how they check the IDS against the IFC. So we have the hard codes, AK. We have Solibri. Nice. And I think that was it, right? That was it. Okay. So try to do 10 minutes each because there's like I said, there's a lot of travel and we also still have the tour. See you at lunch.
Quick message to anyone online. We won't be resuming after lunch with the online again as much as the same as yesterday. So we'll be ending the Zoom call now. Thank you for joining us.